Hey guys, tonight we settle into one of the gentlest ideas in astronomy, the light year. You're here with a screen glow softening the corners of your room, the kind of light that makes everything look a little kinder than it did at noon. Maybe there's a fan turning somewhere. Maybe there's just that late night quiet where even the refrigerator sounds like it's telling a long story very, very slowly. Outside the window, streetlights do their best impression of stars. And the real stars, well, they're up there doing their real job, which is being unimaginably far away while acting casual about it. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like it, drop your location and your local time in the comments. I love picturing all these different corners of Earth, midnight in one place, pre-dawn in another, connected by the same ceiling of stars. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You can begin with a neon hush and a simple promise. 1 year of light. Start small, because your mind likes small. It likes the distance to the kitchen. It likes knowing where the door is. It likes measurements you can feel in your hands. Space doesn't play by those rules, so it hands you a unit that's both familiar and strange. A light year is the distance light travels in 1 year. That's the whole definition. Clean, tidy, almost suspiciously simple. The trick is that the simplicity hides the scale. Light is fast in a way that makes everything else look like it's waiting for a ride. In a single second, if light could skim around the Earth in a perfect circle, it would make a little over 7 laps. Meanwhile, you and I can barely find matching socks without a full investigation. That difference between your human pace and light's relentless pace is what makes the light year feel soothing in a weird way. It's a reminder that some things in the universe are steady. Some things don't hesitate. So take that speed, let it run without stopping for a whole year, and you get a distance so large your instincts kind of sit down. In numbers, a light year is about 9.46 trillion kilometers. If your brain responds with, "Cool, I hate that, that's normal," trillions don't land softly in human imagination. You don't really picture them. You accept them, like you accept that the ocean exists even if you can't hold it all at once. Instead of wrestling the number, you lean into the image, light leaving a place and just going. No traffic, no corners, no fatigue. Just a straight, silent glide through space. And here's where it becomes relaxing. The light year is basically the universe being polite. It's a measurement size for the story we're trying to tell. You wouldn't measure the length of your bed in atoms unless you were determined to ruin a nice evening. In the same way, you wouldn't measure the distance to a star in everyday units unless you wanted to turn wonder into homework. The light year keeps the wonder intact. It's a way of saying, yes, it's far, but we can talk about it without suffering. When you look up at the night sky, really look, even if you're doing it in your head right now, you're not seeing a decoration. You're seeing light that has traveled. The stars are not pinned to a black dome. They're suns. Some are bigger than ours, some smaller, some hotter, some cooler, all of them doing their own thing with a kind of cosmic indifference that's honestly inspiring. That indifference is part of the calm. The universe isn't in a hurry. It's not trying to impress you. It just operates. Light becomes the messenger across all that space. Every tiny packet of starlight is a postcard with no words on it, because the light itself is the message. Something happened there. Something shone. Something existed. You didn't have to request it. It arrived anyway, and you're built to receive it. Your eyes, soft little sensors wrapped in feelings, catch those photons and turn them into star, moon, streetlight, reflection on a glass of water. That transformation is ridiculously intimate for something that starts so far away. You're taking a piece of the universe and letting it end inside you as an image. The distances, though, are what quietly rearrange your sense of far. Across your room is far in a way you can navigate with bare feet. Across a city is far in a way you plan for. Across an ocean is far in a way you respect. A light year is far in a way that makes the word feel like it needs more space around it. It's distance measured with patience, because light is the one doing the traveling, and it doesn't stop to check in. Try a gentle ladder of examples, just to let your mind step into it without tripping. The moon is close enough that light reaches you in just over a second. That's basically instant in human terms. Blink, and you're already behind. The sun is farther. Its light takes about 8 minutes to arrive. 8 minutes is a tiny slice of time, but it's also long enough to make the universe feel real. If the sun vanished, don't worry, it's not taking suggestions. The sky would keep shining for 8 more minutes. That's how honest light is. It doesn't gossip, it just arrives when it arrives. Stars push that feeling into a deeper quiet. The nearest ones are so distant that you stop counting in minutes. You start counting in years. Not because it's dramatic, but because it's accurate. And accuracy can be calming. It keeps you from pretending the universe is smaller than it is. Imagine a single beam leaving a lighthouse at the edge of a dark sea. You can picture it because you've felt what it's like to look across water at night. The darkness isn't empty. It's full of distance. Now swap the sea for space, colder, darker, and even more open, and that beam is starlight. It travels for so long that the travel itself becomes part of the story. A light year is that story turned into a unit. It's what you get when the fastest thing we know keeps moving for the length of all your seasons. Your rainy weeks, your dry mornings, your birthdays, your random Tuesdays, and never slows down. The idea is almost meditative. It makes your mind stretch without straining. And stretching does something nice. It takes the sharpness off your day. That awkward moment you replayed earlier? Still there, sure. The annoying email? It happened. But in a universe where we measure distance by how far light can go in a year, your problems don't disappear. They just stop acting like the main character. They become a side note, like a car passing in the distance while you stay safe in bed. That's the gentle power of scale. It doesn't invalidate your life. It just loosens the tight grip of urgency. There's also something quietly poetic about the name light year. Science gets accused of being cold, and sometimes it is, but this phrase sneaks warmth into precision. It doesn't say 9.46 times 10 to the 12 kilometers. It says light year, like a small lantern you can carry into a very big room. So picture this, a tiny spark leave your screen right now. It slips through your wall, out into the neighborhood, past rooftops and power lines. It crosses the ocean without noticing the waves. It passes the moon like a familiar face. It moves past planets like streetlights on a highway. It keeps going through a quiet that's so vast it starts to feel like a soft blanket rather than a void. A year later, that spark is a light year away from where it began. Still moving, still the same speed, still not thinking about you at all, which, if we're being honest, is a relief. The universe is not grading you. It's not keeping a list. It's just expanding, shining, and sending light outward like an effortless habit. And you get to sit here, warm enough, breathing slowly, holding the definition close without squeezing it. A light year is the distance light travels in 1 year. It's a simple sentence with a huge silence behind it. Let that silence be calm. Let it be spacious. Let it make the night sky feel less like a ceiling and more like an open place that asks nothing from you. Only that you notice how far can really be and how gentle it is that the universe gives you a way to say it. That sentence from a moment ago stays in the room with you like a soft afterimage. Distance traveled in 1 year, and your brain does the thing it always does with language. It tries to turn the words into something comfortable. The word year sneaks in and makes it feel like time, like a calendar page, like something you can schedule. It's almost unfair. Light year sounds like time the way cupcake sounds like it contains a cup. English is adorable like that, and also wildly unhelpful. So you catch the most common misunderstanding before it gets cozy. A light year is not a measure of time, no matter how badly your brain wants it to be. It's a distance, a length, a cosmic tape measure with a poetic label. If someone says a star is 4 light years away, they're not saying it takes 4 years to get there by spaceship, or that it's 4 years old, or that it's open 4 years a week like some kind of interstellar bakery. They're saying the light leaving that star needs 4 years to reach you. Distance told through travel time because the traveler happens to be light. That's a subtle difference, and it matters. It's the difference between thinking space is a timeline and realizing it's a landscape. You've already felt how comforting that landscape can be. The scale quiets the noisy parts of the day. But clarity is even more relaxing than scale because confusion keeps your mind awake. Confusion is a tiny itch behind the eyes. Clarity is a smooth sheet. So picture a long hallway in a hotel at night. Same carpet pattern repeating, doors evenly spaced, the quiet hum of air conditioning. Time is you walking down it. Footstep, footstep, footstep. Distance is the hallway itself, the length of carpet under the lights. A light year is the hallway length, not your footsteps. Light is just the walker we all agreed to use because it's dependable and frankly unstoppable. Scientists love dependable. Astronomers are dealing with distances that make everyday units feel like trying to measure a mountain with grains of sand. You could do it technically. You could count kilometers to a star the way you could count grains on a beach. But you'd be doing it to punish yourself. So they scaled up the ruler until it matched the room. That's what the light year does. It makes the universe speak in sentences you can hold without dropping. And once you accept it as distance, the whole night sky starts behaving differently. The stars stop being up there and become out there, placed in a three-dimensional map, spaced apart with intention, like lanterns on a dark hillside rather than glitter glued to a ceiling. You start to sense that between those lanterns is not nothing, but a huge amount of something very thin. Space, dust, gas, the occasional lonely atom, and a whole lot of quiet. The quiet is the point. A light year gives you a way to describe that quiet without panic. It's a word that says, yes, it's a long way, and that's okay. And because it's distance, you can stack it. 10 light years. 100. 100,000. You can scale up smoothly, like zooming out on a map where your neighborhood becomes your city becomes your country becomes a continent, and then the whole planet is just a blue dot with weather. That zoom-out feeling is the heart of astronomy, and it has this accidental side effect. It makes your personal worries look less like cliffs and more like pebbles. Still real, still there, just not towering. But the best part is how practical it is. The light year isn't just a pretty word, it's a working tool. Astronomers use it in the same way a carpenter uses inches or a sailor uses nautical miles. It's a unit that fits the job. In the solar system, even the light year is too big. If you try to describe the distance from Earth to the Sun in light years, you'd end up with a decimal so small it would look like your calculator was giving up. So for nearby space, astronomers use the astronomical unit, the distance from Earth to the Sun, as a more comfortable yardstick. It's like measuring a room in feet instead of miles. Your brain relaxes because the numbers stop screaming. Then, as you push outward to the stars, you graduate into light years because the astronomical unit becomes too tiny. That change of units is a quiet admission. The universe is not built for human convenience. Humans just keep inventing better rulers. And there's another ruler that shows up a lot in astronomy, the parsec. It sounds like something you'd order at a space-themed cafe. The parsec is also a distance unit, and it's tied to how astronomers measure star distances using a technique based on tiny shifts in a star's apparent position as Earth moves around the Sun. A parsec is about 3.26 light years. So when you hear professionals casually say a few parsecs, that's just their way of speaking comfortably in their native distance language. Light years and parsecs sit side by side like two different brands of tape measure. Same job, slightly different markings. Both try to keep the cosmos from turning into a migraine. You don't need to memorize any of it, and you definitely don't need to do math in bed. But knowing these rulers exist is calming in itself. It means the universe has been visited by enough patient minds that they built tools to describe it without losing their minds. That patience can rub off on you. Also, the light year has a nice human rhythm. It's anchored in something you know, a year, seasons. The Earth's loop around the sun. That's your home clock. Using it to define distance is kind of like bringing a familiar heartbeat into a very large, very dark room. And it's not just about making numbers manageable. It's about making meaning manageable. Because the moment you say light year, you're not only saying how far something is, you're also hinting at how long its light has been traveling to reach you. Even though it's still distance, the travel story comes bundled in for free. That's why the misunderstanding is so common. The unit carries two ideas at once: the size of the gap and the time a beam of light spends crossing it. It's distance with a built-in whisper of history. That whisper changes the way you imagine space. Instead of thinking of stars as fixed points, you start thinking of them as senders and receivers in a very slow conversation. You, right now, are receiving messages that left their sources long ago. Some left before you were born. Some left before your grandparents were born. And they arrive without drama, without fanfare, landing in your eyes like tiny, silent snowflakes. That's almost absurdly intimate. Something shines on the far side of a vast gap and ends as a faint sparkle on your retina. The distance is huge, but the connection is direct. No middleman, just straight-line honesty. And because light is so fast, it makes space feel traversable in the imagination, even when it's not traversable in reality. Your body can't cross a light year the way light does. Your body needs air, food, warmth, protection, and a strong preference for not being blasted by radiation. Light doesn't care. It slides through vacuum as if vacuum is its favorite hobby. So the universe uses light as its courier, and humans use light as their measuring wheel. It gets even more soothing when you realize how consistent this is. Light doesn't speed up because it's bored, and it doesn't slow down because it's tired. It behaves with a steadiness that feels almost moral. In a world full of changing plans and flaky group chats, there's something reassuring about a constant. If you're the kind of person who likes little mental anchors, you can keep a few gentle benchmarks. The sun's light, about 8 minutes. The moon's light, about a second. A light year, light running nonstop for an entire year. From there, everything else becomes a matter of scale, like turning the volume knob rather than trying to rewrite the song. And there's a kind of gentle sarcasm in how humans name things. We call it a light year, and then spend the next century clarifying that it's not time. Classic. The universe hands you wonder, and humans immediately mislabel it like a file on a messy desktop. Still, the label works because it invites you in. It sounds approachable. It doesn't sound like a laboratory. It sounds like something you could mention in a calm voice and still feel the night sky open up behind your words. So the next time you hear a distance in light years, your mind can do a small, satisfying correction without effort. Distance, not time. A ruler, not a calendar. A length measured by the most reliable traveler we know. And with that small correction, the scene becomes clearer. The dark between stars is not a vague blur. It's a measured expanse. It's a space you can name, a gap you can quantify, a quiet you can respect without fearing it. The light year doesn't make the universe smaller. It makes your grasp of it steadier. The glow from your screen, the streetlight outside, the starlight you imagine above the roofline, they're all versions of the same phenomenon. Light traveling. Some of it takes a fraction of a second. Some of it takes years. When you hold that in your mind, the room feels softer, as if the walls are less like boundaries and more like a pause before something immense. And that immense thing doesn't demand you understand all of it tonight. It only offers a simple ruler and a quiet thought. Distance can be told as a journey, and the journey can be told without rush. That steadiness you just felt, the relief of knowing its distance, not time, settles in your chest like a smooth stone you can keep in your pocket. And once your mind stops tripping over the label, it starts noticing the real character behind the measurement. The traveler. Light, the most dependable messenger the universe ever hired, mostly because it never calls in sick. You've heard the number before, even if it was years ago in a classroom with fluorescent lights and a teacher who looked personally offended by joy. The speed of light in a vacuum is 299,792,458 meters per second. It's oddly specific, like the universe is showing off a little. Not about 300 million. Not roughly. It hands you a full, crisp integer, 8 digits long, and it doesn't apologize. That specificity has a quiet kind of comfort to it. A lot of life feels approximate. You estimate how long it'll take to get somewhere. You guess how someone will react. You kind of remember where you put your keys. Light doesn't do kind of. Light commits. And in a way, you can treat that speed like a lullaby rhythm, a cosmic metronome ticking under everything you see. Not a harsh tick-tick-tick. More like a soft pulse you don't hear with your ears, but feel as the backbone of reality. Every bit of starlight arriving tonight keeps the same beat. Every glare off a window, every little sparkle on water, every gentle glow from your screen. It's all moving at that speed in the emptiest parts of space, like the universe's default setting. What makes it even stranger, strangely soothing, is that this number isn't just something humans measured. Humans ended up defining things around it. The meter itself, in modern science, is tied to the speed of light. So it's not only that light moves at 299,792,458 meters per second. It's that the meter is defined so that light moves at exactly that speed. The universe gave a constant, and humans quietly reorganized their rulers to match it, like rearranging furniture so the sunlight falls perfectly on the floor. It's an intimate kind of agreement. You don't control the cosmos, but you can choose how to describe it with honesty. And honesty matters in a room like this, late, quiet, half-lit, because your mind is sensitive right now. It notices when things are fuzzy. It notices when something doesn't quite fit. A constant that behaves the same way everywhere is like a clean line drawn across a messy page. You can follow it without effort. Of course, the universe is also a little mischievous because light speed depends on what it's traveling through. In glass, in water, and air, it slows down. Not because it's tired, but because interacting with matter is complicated. Photons don't just stroll through a crowd. They get delayed by the subtle dance of atoms and electrons. It's like trying to cross a busy kitchen while everyone is opening drawers at once. Still possible, still graceful, just not the same as moving through an empty hallway. That's why the phrase "in a vacuum" matters. Vacuum is the emptiest kind of stage, where light gets to perform its pure speed without bumping into anything. Out between the stars, where the space is so thin you could almost call it nothing without being completely wrong, light is nearly always at its full cosmic pace. And that pace becomes the gentle boundary of how the universe allows cause and effect to behave. It's the speed limit of information. No signal, no influence, no "hey, look over here" can outrun it. That sounds restrictive until you sit with it for a moment and realize it's also protective. Because if information could travel instantly, the universe would be a chaotic place. Everything would affect everything else immediately. No buffer, no delay, no room for anything to unfold. Instead, the speed of light gives the cosmos a calm structure, like spacing between notes in music. It prevents reality from collapsing into one loud, overwhelming chord. So when you think of light traveling a light year, you're not only thinking of distance. You're thinking of the maximum pace at which the universe lets stories move from one place to another. That makes the night sky feel like a library of messages arriving on schedule, each one carried by the same reliable courier, each one arriving when it can and not a second sooner. And you don't have to fight that. There's something strangely therapeutic about a universe that refuses to be rushed. Even your brain likes it, because your brain is built around delayed signals too. Nerves don't transmit instantly. Your thoughts don't appear fully formed without a moment of assembling. You're a creature of tiny weights and little transmissions, and light just happens to be the champion of that same principle on a cosmic scale. It's like finding out the universe shares your pacing problems, except it's better at them. If you want to feel that speed without drowning in numbers, let it become imagery instead. Picture a flashlight turning on in a dark field. In your everyday life, the beam seems immediate, like it simply appears. But technically, it's racing outward in a spreading front, filling space with brightness at that enormous speed. The reason it feels instant is that your room is small compared to how fast light moves. Shrink your ego a little, gently like loosening a collar, and the same idea scales up. The solar system is big enough that light takes minutes to cross it. The gaps between stars are big enough that light takes years. The gaps between galaxies are big enough that light takes millions of years. And through all of that, the speed itself stays steady in the empty places. The universe changes the size of the stage, not the tempo of the performer. There's a lovely irony hidden in the history of how humans pinned this number down. For most of human existence, light was basically magic. Lightning, flames, the sun, the shimmering edge of dawn. People argued about whether it traveled instantly or took time. At one point, the debate wasn't about millions of meters per second. It was about whether it moved at all or was simply there. Then came experiments, careful and patient. People watched moons of Jupiter disappear into shadow and reappear, noticing tiny delays when Earth was farther away and shorter delays when Earth was closer, like listening to a drummer from different ends of a stadium. Those delays hinted that light had a finite speed. Not infinite, not instant. Fast, yes, but still a traveler. Later came more precise measurements, spinning mirrors, timed reflections, all that beautiful human stubbornness to quantify what seems untouchable. And eventually, instead of chasing the number with better and better tools, humanity did the most human thing possible. It made the number part of the definition of the tools. If you can't stop refining the ruler, define the ruler so the thing you're measuring becomes exact by agreement. It's a cozy form of control, not over the universe, but over your descriptions of it. So that number, 299,792,458, can sit in your mind like a secret password to scale. You don't have to repeat it like a chant. You just let it be there, proof that there are places in nature where things are consistent. Places where maybe doesn't apply. And because it's consistent, it becomes a bridge. It connects the glow in your room to the glow of a star. It connects your small, present moment to the far edges of what you can imagine. It connects distance to time without confusing them, because the relationship is clean. Distance equals speed times time. The speed is the anchor. The time is the duration. The distance is the result. Your brain relaxes when it sees something that behaves. Even the way the number is written has a calming, step-like structure. It starts with 2, then 9s, then 7, 9, 2. It feels like a code you can trace with your finger. And somewhere in that tracing is the quiet reminder that nature doesn't have to be messy to be vast. Vastness doesn't automatically mean chaos. There's also a gentle, sleepy joke in how humans react to this speed. We hear the speed of light, and our first instinct is to build stories about breaking it, outrunning it, bending it, making it our personal servant. Because humans can't meet a boundary without poking it. Meanwhile, light just keeps moving, unimpressed, as if to say, you can fantasize all you want. I'll be over here being fundamental. That's not cruel. It's clarifying. And clarity is what you came for, even if you didn't realize it. Clarity is what lets your mind stop sprinting. When you understand that the speed of light isn't just fast, but also woven into the way space and time relate, you stop trying to force the universe into everyday intuition. You stop asking it to behave like a neighborhood. You let it be what it is: large, structured, patient, and beautifully consistent. So the light year becomes even gentler in your hands. It isn't a random unit somebody made up to sound cool. It's built on a constant that acts like the universe's heartbeat. 1 year of that heartbeat, moving outward without pause, give you a distance that's so big it makes you quiet, and that quiet can feel like relief. Your breathing slows a fraction because the idea itself is steady. A beam leaves a source, travels at a fixed pace through the emptiest space, and arrives. Nothing dramatic. No noise. No struggle. Just motion and distance, and the calm fact that the universe keeps its promises, at least in this one very important way. That steady heartbeat of light keeps moving in your mind, and it does something sneaky. It makes the biggest numbers feel less like a threat and more like scenery. The room stays quiet, your breathing stays easy, and the universe, being the universe, offers a simple next step. Instead of staring into the deep end, where distances turn into millions and billions of light years, you hover closer to home. Not home, like your address, more like your son's little patch of the galaxy. The local neighborhood, the part of the Milky Way where the stars are still close enough to feel like neighbors. Very distant neighbors who never borrow sugar, because interstellar space is not big on community. If you could lift the sky like a blanket and look underneath, you'd find that the stars around you aren't evenly sprinkled. They're scattered in 3 dimensions, like a handful of glow beads tossed into a dark swimming pool. From Earth, you see the projection, flat, pretty misleading. The constellations are basically a cosmic coincidence board. Great for stories, terrible for knowing who actually lives next door. The nearest star system is the Alpha Centauri group, sitting about 4.3 light years away. That number has a cozy ring to it. 4-point-something, like the distance to a cafe if you're willing to walk. Except the walk is light traveling for more than 4 years, which is a minor detail that ruins the casual vibe. Alpha Centauri is actually a little family. 2 sun-like stars, Alpha Centauri A and B, together in a smaller red dwarf called Proxima Centauri that hangs out in the same neighborhood. Proxima is the closest individual star to our Sun. It sits at about 4.24 light years. That means the faint red light from Proxima that reaches Earth tonight left there more than 4 years ago. Back then, Earth was still Earth. Same oceans, same clouds, but you were in a different version of your life. Different day to day, different worries, different playlists. Meanwhile, that light was quietly crossing the dark, never changing its speed, never checking the time, just heading for your eyes like it had an appointment. There's something comforting about that. Even the nearest stars are far enough to make human drama look temporary, but close enough that you can almost name them like neighbors on a street. Proxima is a red dwarf, which is the most common kind of star in the galaxy. Red dwarfs are small, cool, and persistent, like the universe's practical choice. They burn their fuel slowly and can last for a very long time. If stars had personalities, red dwarfs would be the ones who show up early, stay late, and quietly keep things running while flashier stars take the spotlight and burn out dramatically. It's hard not to respect that. And because Proxima is so close, it's become a favorite for planet hunters. It has at least one planet roughly Earth-sized in the right distance range where liquid water could exist under the right conditions. Whether it's actually pleasant, there is another story. Red dwarfs can be a bit moody, throwing flares that make sunburn feel like an understatement. Still, it's a soothing thought. The nearest star to us isn't just a lonely lamp in space. It's a small system with its own worlds, its own nights, its own daybreaks, happening while our own world turns and sleeps. Move a little farther, and you start meeting other familiar names, the kind that show up in astronomy books and sci-fi stories, because humans are incapable of seeing a map without plotting dreams on it. Barnard's star, for example, sits about 6 light years away. It's a dim red dwarf too, and it's famous for how quickly it moves across our sky compared to most stars. That motion isn't because it's impatient. It's just close enough and moving through space in a way that makes the shift noticeable over time. The sky feels fixed when you're human. Stars teach you that fixed is just slow. Another close one is Wolf 359, around 7.9 light years away, also a red dwarf. Then Lalande 21185, about 8.3 light years. Names like that have a sleepy charm. Slightly awkward, very official, like the universe's filing system. They don't sparkle linguistically, but they're honest. They're the labels on drawers in the galaxy's cabinet. Then there's Sirius, the brightest star in our night sky. And this is where your intuition gets gently roasted. Sirius looks like a headliner. It's the kind of star people notice without trying. It sits in the constellation Canis Major, and it shines with that sharp, white confidence that makes it feel close, like it's leaning toward you. It's not particularly close. It's about 8.6 light years away. Still very much in neighborhood, but not next door. It's simply bright because it's luminous and relatively nearby compared to most of the stars you can see. That's the first quiet lesson of the local map. Brightness is not a distance label. Brightness is a combination of what the star is and how far it is. The sky can be deceptive like that. It's basically a glamorous liar. Sirius is also a double system. Sirius A, the bright star you see, and Sirius B, a white dwarf, an incredibly dense, compact remnant of a star that used to be larger. A white dwarf is what happens when a star like the Sun finishes its main life and leaves behind a hot, small core. Imagine compressing something roughly the mass of the Sun into something about the size of Earth. The density is so intense it stops being a number and becomes a feeling. A feeling like the universe really does whatever it wants. And even that can be calming in a strange way, because it means nature has rules, but those rules allow for wildly different outcomes. Soft red dwarfs humming along, bright stars shining hard, and tiny white dwarfs sitting there like cosmic embers that refuse to go out. Vega is farther, about 25 light years, but it's another star that people recognize because it's bright and prominent. Arcturus is around 37 light years. These aren't neighbors in the same way, but they're still in the broader local district, the part of the galaxy close enough that you can start to think of it as a region rather than an abstraction. And here's the cozy part. If you could draw a map of the stars within, say, 15 light years, it wouldn't feel infinite. It would feel like a sparse town on a dark plain. You'd see the Sun in the middle, and around it, scattered points, Proxima and its companions, Barnard's star, Sirius, a handful of others. Lots of gaps, mostly empty space. The emptiness is what makes it peaceful. Space isn't crowded. The universe gives everything room. This region is sometimes described as part of the local bubble, a low-density area of interstellar space that the Sun happens to be traveling through. It's like our solar system is drifting inside a thin patch of gas, a kind of cosmic clearing. Even the stuff between stars has neighborhoods. Even emptiness has texture. If that sounds too abstract, make it simple again. Between you and Proxima Centauri is mostly nothing. Not absolute nothing. There are stray atoms and thin wisps of gas, maybe a few dust grains wandering like forgotten confetti. But compared to air in your room, it's emptiness so extreme it's basically a lullaby. And that emptiness is what makes starlight possible across years. Light can cross because it isn't constantly being stopped and scattered. It travels through a darkness that's not hostile, just open. It also means the idea of near in space is different from near on Earth. On Earth, near implies you could get there with enough time, fuel, and a decent playlist. In space, near is more like you can name it, you can measure it, you can study it with instruments, and its light reaches you in a time frame that still feels personal. For years, 8 years, 10, that's within a human memory. You can imagine where you were 4 years ago. You can feel how long 8 years is. So when you hear those distances, you're not only grasping kilometers or meters, you're holding a slice of your own timeline as a way to understand the gap. And without meaning to, you start forming a kind of intimate relationship with the stars around you. Not romantic, don't make it weird, but familiar. They become fixtures in the local night, like quiet houses you pass on a street you've walked many times. There's also a subtle thrill in how these close stars shift the idea of alone. The Sun is one star among hundreds of billions in the Milky Way, but in its immediate neighborhood, it still has company. The nearest stars are far, yes, but they exist, and their presence means the galaxy is not just a distant city. It's a place with nearby lights. In your brain, which likes to build stories, starts connecting them. It pictures a triangle between the Sun, Proxima, and Sirius. It imagines thin threads of light traveling back and forth like slow conversations. It imagines civilizations, maybe not, looking up at their own skies and seeing our Sun as a star, and there's faint and ordinary. If someone lived on a planet orbiting Proxima Centauri and looked toward our solar system, our Sun would just be another point of light. Not bright, not special, just a star in a crowded, glittering background. That thought is both humbling and soothing. It means the universe isn't centered on you, which is honestly a relief on nights when you're tired of being responsible for everything. The local sky becomes even more interesting when you remember that what you see is delayed. Proxima's light is from 4 years ago. Sirius's is from 8.5 years ago. Barnard's star is from 6 years ago. So this little neighborhood map you're building isn't a map of right now. It's a map of staggered moments, each one arriving on its own schedule. You're looking at a collection of events arranged in the shape of a now. That's not spooky, it's gentle. It means the sky is a record, a calm archive. The light year is the unit that lets you read it without panic. So the close stars stop being distant decorations and start being landmarks, measured, named, positioned in a quiet geometry around the Sun. The numbers don't feel like a wall anymore. They feel like a layout. And a layout is something you can relax into because it suggests order. The universe near us has order. A sparse neighborhood of stars, most of them small red dwarfs, some brighter and bigger, some dense remnants, all separated by huge calm gaps. Your mind can rest in that order. It doesn't have to solve anything. It can simply inhabit the sense of scale, the sense of place, and the soft realization that even next door in space is measured in years of light, yet still somehow feels approachable when you let the universe set the pace. That sense of a local neighborhood. Proxima like the quiet house a few blocks over, Sirius acting bright and important like it pays rent in confidence, starts to feel almost manageable. Manageable is a dangerous word in astronomy because the universe hears it and immediately expands the room. Your mind has been holding distances like 4 light years and 8 light years, numbers you can turn over without dropping. Then you glance outward just a little, and you realize those neighbors are still standing inside a much larger structure, the way a handful of porch lights sit inside a whole city grid you can't see from street level. The Milky Way is that city. From Earth you see it as a pale band across the night, a soft spill of light like someone brushed chalk across black paper. It's pretty, it's quiet, it's easy to mistake for a cloud. But that band is the combined glow of an enormous number of stars, most of them too faint and too crowded to separate with the naked eye. You're looking through the plane of the galaxy, across a dense, flattened disk packed with suns. The Milky Way isn't a decoration overhead. It's the view down the lane of the neighborhood you're already in. And the moment you accept that, the light year stops being a fun fact and becomes a map scale. The Milky Way's disk is roughly 100,000 light years across. Give or take, because galaxies are not the kind of thing you can outline neatly with a marker. They fade at the edges. They have wisps. They have halos. Still, about 100,000 light years is the sort of sentence that feels like it should come with a chair and a deep breath. If you try to hold that next to the distances you were just imagining, it would be like comparing the width of a human hair to the length of a highway. The Sun's neighborhood, those stars within 10 light years, even 20, is a tiny, cozy corner. Akudusak, the Milky Way is the whole metropolitan sprawl, and you're not in the center of it, because of course you're not. The universe doesn't hand out main character coordinates. The Sun sits in the galaxy's disk, about 26,000 to 27,000 light years from the center. That means light leaving the galactic center would take around 27,000 years to reach you. The last time that light began its trip, humans were not building skyscrapers or sending emails. Human civilization, as you know, it wasn't even a sketch. That light has been traveling through the galaxy the whole time, crossing star fields and dust lanes, and it arrives as an ordinary fact. The center is there. When you hear that, the brain does something interesting. It stops trying to picture the whole thing because it can't, and it starts to feel it instead. The Milky Way becomes not an object, but an environment, like weather, like ocean depth, like night itself. Something you live inside. And because you live inside it, the structure isn't obvious. If you're standing in a forest, it's hard to see the shape of the forest. You see trunks, leaves, shafts of light, the occasional clearing. You infer the rest. That's what astronomers do with the Milky Way. They build a mental model from the inside, using light that reaches us from different directions, different distances, different layers of dust. It's like trying to describe a city while you're stuck in traffic on one street. You can still do it, but it takes patience and creative measurement. The broad picture is comforting in its simplicity. A disk with spiral arms, a central bulge, and a halo of stars around it. Spiral arms sound dramatic, like something that should roar. In reality, they're more like gently denser regions where stars and gas tend to gather, shaped by waves of gravity moving through the disk. The arms are not rigid, not like the arms of a pinwheel made of solid material. They're patterns, lanes, traffic flows. Stars drift in and out over time, the way cars move through a city's busiest avenues. The pattern persists even as the individual participants change. That idea, pattern over panic, is soothing. Your life is individual moments. The galaxy is a pattern held together over hundreds of millions of years. The sun sits in a small feature called the Orion Arm, sometimes called the Orion Spur or local spur. Spur is such a modest word for a structure measured in thousands of light years, but it fits the vibe. It's a smaller branch between two bigger arms, the Sagittarius arm on one side and the Perseus arm on the other. So even your galactic address is a little sideways, a little tucked in, like you live on a quieter street between the main boulevards. And that quieter street is still packed with wonders. The Milky Way contains hundreds of billions of stars, and the range of those stars is the kind of variety that makes your mind loosen its grip on normal. There are red dwarfs humming patiently for unimaginably long lifetimes. There are hot, bright blue stars that blaze through their fuel like they're trying to win a contest no one asked them to enter. There are giant stars swelling in old age. There are remnants, white dwarfs like Sirius B, and neutron stars and black holes, quiet leftovers of stars that change shape and refuse to disappear completely. At the very center of the Milky Way sits a supermassive black hole, known as Sagittarius A star. It's not a vacuum cleaner sucking everything in with cartoon violence. It's more like an anchor of gravity, surrounded by stars orbiting at high speed, all of it mostly calm until something gets too close in the wrong way. The black hole's presence gives the center its intense gravitational character, and for most of the galaxy, it's simply part of the layout. A deep center you don't visit, like the ocean trench beneath a ship. It exists, it shapes things, and you don't have to go near it to feel the structure of the whole. Even the thickness of the galaxy has a quiet elegance. The disk is thin compared to its width, only a few thousand light years thick in many places. That means the Milky Way is more like a vast, flat plate than a sphere. The stars in the disk mostly orbit in that plane, circling the center like slow, patient commuters. The Sun is one of them, taking about 225 to 250 million years to complete one orbit around the galactic center. One galactic year is so long that the number stops being something you count and starts being something you accept, like the age of mountains. It's calming to realize you're moving through space, even while you're lying perfectly still. You're spinning with Earth. You're orbiting the Sun, and the Sun is orbiting the galaxy. Everything is in motion, but not the frantic kind. It's the kind of motion you don't feel because it's steady and smooth, like being on a large ship in calm water. The Milky Way is carrying you, and it's doing it without asking for your opinion. The light year helps because it turns that motion into distances that make sense at the galaxy's scale. The nearest stars are measured in a handful of light years. The nearest spiral arm features the thickness of dust lanes, the distance to the center. Those become thousands and tens of thousands. Suddenly, the numbers match the room. It's like switching from whispering to speaking at a normal volume. And when you look at the Milky Way band in the sky, you're looking along the disk through a thicker concentration of stars and dust. Dust matters here in a way that feels almost domestic. Dust is everywhere, on shelves, on windowsills, on the black velvet of interstellar space. In the galaxy, dust absorbs and scatters visible light, especially over long distances, so it can hide stars behind it like a curtain. That's part of why the Milky Way looks patchy, bright in some places, dark in others. Those dark lanes are dust clouds, the galaxy's soft smudges. The funny part is that the dust that blocks your view is also the dust that helps build new worlds. In dense regions, dust and gas can collapse under gravity and form new stars. And around those stars, planets can take shape. So the Milky Way's mess is also its creativity. The same stuff that obscures is also the stuff that makes. That relationship between hiding and making adds a gentle mystery. The galaxy is not fully revealed to the eye. It's partially veiled, like it's keeping a few secrets for the sake of romance. And your mind loves that. Your mind likes to know there's more behind the curtain, even if you're too sleepy to pull it back. In the broader structure, beyond the disk and its arms, there's the halo, a more spherical region around the galaxy with older stars and globular clusters. Globular clusters are dense, round gatherings of stars that orbit the galaxy like ancient lanterns. They're some of the oldest structures around, and they carry this feeling of deep time, stars that have been shining since long before Earth had anything resembling a YouTube subscription button. Their existence makes the Milky Way feel like it has layers. Young, busy regions in the disk, older, calmer populations in the halo, a center with its own intense gravity, all of it stitched together by motion and distance. You can sense magnificence without forcing it. Magnificence arrives when you stop trying to dominate the image and start letting it surround you. So your local street of nearby stars becomes part of a spiral feature. The spiral feature becomes part of a disk. The disk becomes part of a galaxy spanning about 100,000 light years. And the light year, this gentle ruler, stays in your hand the whole time, scaling with you, never snapping, never accusing you of being too small to understand. It's almost sweet how the universe lets you climb like this. You begin with a star 4 light years away and end up realizing you live inside a rotating city of hundreds of billions of suns, arranged in arms like luminous currents, drifting around a dark center that holds the whole pattern together. And through it all, the emptiness between stars remains enormous, giving everything space to breathe. The galaxy is crowded with stars in the same way a beach is crowded with grains of sand. There are many, but there's also so much room that a single grain can exist without bumping into another for a long, long time. That's the kind of crowd you can relax in. And somewhere in the back of your mind, that earlier thought about the sky being a glamorous liar comes back with a softer tone. The Milky Way band looks like a gentle mist, but it's actually the densest view you can get of your own galactic home. A quiet glow that represents a structure bigger than your imagination, yet close enough that you can trace it with your eyes on a clear night. Home, in this sense, stops being a point. It becomes a pattern. It becomes a lane of light across a dark sky. The signature of a galaxy you're inside, carried along with steady motion, measured in light years that feel less like math and more like a long, calm breath. That feeling of living inside a rotating city of stars lingers. The Milky Way stretched like a pale lane across the sky, and your mind starts to do what it always does when it finds a pattern. It wonders what's beyond the edge of the pattern. You've been tracing spiral arms like quiet streets, thinking of the galaxy as a place with neighborhoods and a center and a halo, and it almost feels habitable. Not in the pack-a-suitcase sense, but in the my brain can hold this without overheating sense. Then you drift outward far enough that the city lights thin out. The Milky Way stops being an endless crowd and becomes a single island of light. One luminous swirl hanging in a darkness that suddenly feels larger than the galaxy itself. That's the moment the light year starts acting like a boat instead of a ruler, because the distances between galaxies aren't just bigger numbers. They're different kinds of far. They're the kind of far that feels like open water at night. No landmarks, no street signs, just long, patient space in every direction. Galaxies are not politely packed together like houses. They gather in groups and clusters, sure, but even in those gatherings, the gaps are enormous. The space between galaxies is mostly quiet, and it's quiet in a way you can almost hear if you listen with your imagination. Not silence like nothing exists, more like the hush inside a giant cathedral when everyone has gone home and the air itself seems to be resting. Start with the nearest stepping stones, because your mind still likes a handrail. The Milky Way has companions, small satellite galaxies that orbit it, like tiny lanterns caught in the gravity of a larger flame. Two famous ones are the Magellanic Clouds, visible from the southern hemisphere, drifting nearby on the galactic scale. They're not between galaxies in the full sense, but they hint at the truth. Even a galaxy has company, and the company comes in different sizes. Then your attention slides to the real next big neighbor, Andromeda. The Andromeda Galaxy is about 2.5 million light-years away, which is the point where neighbor starts sounding like sarcasm. That number is so much larger than anything you've been holding so far that it reshapes your internal map. 2.5 million light-years means the light you see from Andromeda tonight began its journey when early humans were still learning how to be human. Stone tools, long walks, fires, the sky, still the same canopy overhead, just seen through different eyes. And that light has been crossing intergalactic space for all that time, through a darkness that isn't empty, but is so thin it might as well be a dream. A few stray atoms here and there. A faint haze of gas. Some wandering dust. It's not the kind of substance you can scoop up. It's more like a suggestion of matter, spread so widely that vacuum starts sounding like a compliment. The ocean metaphor fits because intergalactic space has that same emotional texture. Deep, cold, and strangely calming once you stop expecting it to behave like a room. In a room, emptiness feels unfinished. In intergalactic space, emptiness feels intentional. It feels like the universe built vast, quiet zones on purpose, the way a composer leaves rest in music so the notes can mean something. Andromeda itself is a full galaxy, a spiral like the Milky Way with hundreds of billions of stars. It's not a single destination, it's another city of suns. Thinking about that while you lie still is a gentle kind of absurdity. Your body is soft, warm, and completely unconcerned with traveling 2.5 million light-years, and yet your mind can cross that distance in a single thought. The mind is the only thing you own that can do that without fuel. The gap between the Milky Way and Andromeda is not a clean, empty gulf either. It has structure, just subtle structure. Both galaxies sit in a small family called the local group, dozens of galaxies bound together by gravity. You can imagine it like a loose archipelago, islands of stars with long stretches of dark water between them. And the water is that intergalactic medium, thin gas stretched across the group, with the occasional stream of material drawn out by gravity like tidal currents. Gravity is the quiet tide in this ocean. It doesn't splash. It doesn't shout. It simply pulls, patiently, over millions of light years, shaping who gathers with whom and how the cosmic islands drift. And in that patience, there's a soft lesson you don't have to force. Distance does not equal disconnection. The galaxies are far apart, but they still influence each other. Their gravity reaches. Their motions matter. Their histories tangle. The universe is not a set of isolated objects. It's a web of relationships played out over absurd scales. You might feel the temptation to make intergalactic space sound scary, because humans have a habit of turning large emptiness into horror stories. But the truth is quieter and honestly kinder. The emptiness between galaxies is mostly just calm. It's not filled with monsters. It's filled with time and thinness and gentle background light. Even the darkness there isn't absolute. There's a faint glow everywhere in space. Leftover radiation from the early universe cooled and stretched so much that it's mostly microwaves now, bathing everything in a uniform, whispering background. You can't see it with your eyes, but it exists like a cosmic room tone, the kind you only notice when it's gone. Intergalactic space is never truly black. It's just dim beyond human senses, the way a sleeping room is never truly silent if you pay attention long enough. This is where the light year becomes extra relaxing, because it gives you permission to accept the slow. In daily life, slowness is treated like a problem to solve. Faster shipping, faster replies, faster everything. Intergalactic distances basically shrug at your obsession. They say, very gently, no. Light itself takes millions of years to cross between large galaxies. That's not a failure. That's the scale. It's the universe giving you a pace that nothing on your to-do list can compete with. And if you let that pace wash over you, the mind starts to loosen. The same way staring at a calm sea makes your thoughts spread out and soften. Thinking about intergalactic space can do the same. The sheer amount of quiet between galaxies makes your internal noise feel smaller, like it's happening in one room of a very large house. You can picture the Milky Way and Andromeda as two distant lighthouses across that dark ocean. Each one sends out light continuously, not targeted, not searching, simply shining. Most of that light goes nowhere important. It drifts through space without an audience. A tiny fraction happens to intersect with planets and eyes and telescopes. That randomness is weirdly comforting. The universe isn't performing for you. You're just lucky enough to be in the path of the glow, and the glow carries information. When astronomers study Andromeda, they're not looking at it as it is. They're looking at it as it was millions of years ago, because that's when the light left. That delay turns the gap into a kind of memory lane. The space between galaxies becomes not only distance, but archive. Every extra light year adds another page of history. The intergalactic ocean also teaches you how sparse stuff can be while still being real. In your room, air is thick enough to breathe. Between galaxies, the density is so low that you could travel for ages and almost never hit anything in the way you're used to thinking. Yet even that thin gas matters over time. It can be pulled into galaxies. It can be heated, cooled, stirred. It can feed the slow birth of stars at the edges. Nothing is wasted. The universe is just extremely patient with its recycling. If you stay with the ocean image, it gets even calmer. In the open sea, the most powerful forces are often gentle on the surface. Currents, tides, slow swells. Intergalactic space is like that. The big movements are slow and smooth, guided by gravity and momentum. Galaxies drift through the dark like ships that left harbor long ago and won't arrive for a very long time. You don't see the wake with your eyes, but the wake is there in the way gas and smaller galaxies and star streams are pulled and stretched. There's a quiet magnificence in how little has to happen for the universe to feel full. Two galaxies separated by millions of light years can still feel like a relationship, not a conversation. Conversations are too quick, but a long, slow dance where each step takes epochs. And you, lying here with your screen dimmed and your fan humming, get to imagine it without needing to solve it. The best relaxing fact about this intergalactic ocean might be the simplest. Most of the universe is space. Not stars. Not planets. Space. Vast, generous space. And that means most of existence is not crowded. It's open. It's roomy. It's built with margins. Margins are soothing. Your mind understands margins, even if it doesn't understand millions of light years. Margins are the blank space around a paragraph that lets the words breathe. Intergalactic space is the universe's margin, and galaxies are the paragraphs. Dense, bright, full of stories. The margin looks empty until you realize it's what makes the story readable. So when you think of the Milky Way's spiral arms again, they start to feel like one page in a much larger book. The book isn't chaotic. It's spacious. It's written with enormous pauses between the big luminous sentences. And the light year is the comm unit that lets you measure those pauses without turning them into panic. Somewhere far off, Andromeda's old light keeps arriving, steady as that cosmic metronome you held earlier, crossing the quietest ocean imaginable. It doesn't care if you understand the whole journey. It simply shows up, faint and faithful, and reminds you that even across millions of light years, the universe is capable of gentleness. That intergalactic ocean has a way of making you feel small in the most peaceful possible way, like you've stepped back from your life and found it sitting inside a much larger, calmer frame. And then the practical side of your brain, yes, the one that insists on asking questions at bedtime, clears its throat and goes, okay, but how do we actually know any of these distances? Because saying Andromeda is about 2.5 million light years away sounds confident, almost suspiciously confident, like the universe whispered it into someone's ear and they just wrote it down. The truth is less mystical and more charming. Humans figure it out by blinking, not with eyelids. With Earth. Earth makes one lap around the sun every year, and that motion becomes a built-in measuring stick. It's the most quietly useful thing your planet does, besides keeping you alive. 6 months apart, you're standing on opposite sides of Earth's orbit. The baseline, the width of that orbit, is huge by human standards, but tiny by cosmic standards. And that contrast is the whole magic trick. You already know the thumb trick, even if you haven't done it in a while. Hold your thumb up at arm's length and look at it with one eye closed, then switch eyes. Your thumb appears to jump against the background. The thumb didn't move. You move the viewpoint. Your brain uses that shift, parallax, to sense depth. Astronomers do the same thing with stars, except instead of switching eyes, they switch Earth's position in its orbit. The stars jump ever so slightly against the much more distant background stars. It's not a dramatic leap. It's a microscopic wobble, the faintest hint of a shift. But it's enough. It's enough because geometry is one of the universe's most dependable languages. Numbers can be intimidating, but triangles are comforting. Triangles don't care if you're tired. Triangles don't care if you forgot your password. If you know one side and you can measure the angle, the rest follows. Calmly, predictably, like a lullaby made of lines. So you imagine Earth in January on one side of the sun, then Earth in July on the other side. You point a telescope at a nearby star, the kind of nearby that still sits several light years away, and you compare its position relative to far background stars. The nearby one seems to shift a little left, a little right, like it's gently breathing. That apparent shift is parallax. And the angle of that shift is tiny, so tiny that for centuries, humans argued about whether they could detect it at all. That argument wasn't just academic. It was existential. If Earth truly moves around the sun, nearby stars should show parallax. If they didn't, either Earth didn't move or the stars were so far away that the parallax was too small to see. The universe, in its favorite kind of humor, picked the second option. Yes, Earth moves, and yes, the stars are just that far. When the first parallax measurements finally worked, it wasn't a dramatic thunderclap. It was more like finally hearing a very faint note you were sure was there. A small shift, measured carefully, turning into a distance number that made everyone quietly sit back and reconsider how enormous space really is. The angle is usually measured in arc seconds, which are absurdly small units of angle, because the sky is wide and the shifts are tiny. 1 degree is already a small slice of circle. 1 arc minute is 1/60th of a degree. 1 arc second is 1/60th of an arc minute. The names alone make your brain want to nap, which is perfect. The important part is the feeling. These angles are so small that measuring them is like trying to notice the width of a hair from across a room. It takes precision, patience, and instruments that don't blink at the wrong moment. Here's the gentle beauty, though. Once you have that parallax angle, distance comes out clean. The smaller the parallax, the farther the star. Big shift means close. Tiny shift means far. That's it. No drama. The universe doesn't hide the rule. It hides the angle because the angle is ridiculously small. And this is where that other unit you met earlier, the parsec, starts to feel less like an annoying extra word and more like a convenience that actually cares about your comfort. A parsec is defined through parallax. If a star shows a parallax of 1 arcsecond when Earth moves from one side of its orbit to the other, that star is at a distance of 1 parsec. 1 parsec is about 3.26 light years. So the parsec isn't competing with a light year. It's the same map with a different scale printed on the edge, designed to make the triangle math easier. Light years speak poetry. Parsecs speak geometry. Both are telling the same quiet story. What's soothing about parallax is how gentle it is. No explosions, no exotic physics, just shifting perspective. The universe allowing you to measure distance by moving your head. Essentially, except your head is an entire planet doing a graceful orbit. It's almost absurdly elegant, like discovering you can measure the size of a cathedral by taking 2 slow steps and looking carefully. And it's also deeply human. You can't reach the stars, so you let the stars reveal themselves through the tiniest motion you can manage. You use the resources you have, a stable orbit, careful observation, and the willingness to compare notes across months. It's the scientific version of patience. The limitation shows up quickly, and it's worth feeling rather than fearing. Parallax works best for nearby stars because the angle gets smaller and smaller with distance. For faraway stars, the shift becomes so tiny that it gets swallowed by measurement uncertainty, by the atmosphere's shimmer, by the simple fact that you're trying to measure something almost unimaginably delicate. So parallax is the first rung on a distance ladder. It anchors the scale close to home, where your blink is large enough to matter. Once you have reliable distances to nearby stars, everything else becomes possible. Those nearby measurements let you calibrate other methods, ways of estimating distances based on brightness, motion, and the known behavior of certain kinds of stars. But that's the wider ladder. Parallax is the rung you can trust because it's geometry, and geometry is the kind of truth that feels cool to the touch. There's a mysterious comfort in that. You live in a world where a lot of things feel subjective. People interpret tone differently. Memories disagree. Plans change. But a triangle doesn't get moody. A triangle gives the same answer no matter how you feel about it. So you picture the astronomer's view, 2 snapshots of the same star, taken half a year apart, and the star's position nudged against the distant background. That background is so far away that, for this purpose, it acts like a fixed wallpaper. Not perfectly fixed. Nothing is perfectly fixed in space, but far enough that the nearby star's wiggle stands out. It's kind of like looking out a car window. The fence posts close to the road rush past. The mountains barely move. Your brain reads that difference and understands depth. Parallax is the cosmic version of fence posts and mountains, except the fence post is a star, and the mountain is another star so far away it behaves like the edge of forever. And because your brain likes stories, you can imagine the nearby star feeling slightly self-conscious. Like, yes, I know I'm wiggling. It's not my fault you keep moving. Meanwhile, Earth continues its calm orbit, completely unbothered. The universe's laziest measuring device, just doing its yearly lap and accidentally enabling modern astronomy. It's also a reminder that perspective changes everything. A star doesn't move in the sky because it's wobbling in space. It moves because you moved. The shift isn't out there. It's a relationship between you and the object you're looking at. That's the soft philosophical undertone that makes this feel like more than math. Distance is not only a property of the star. It's a property of your viewpoint, your baseline, your willingness to compare here to there. And what a baseline it is. Earth's orbit gives you about 2 astronomical units of separation between those two observing points, because you're looking from one side to the other, roughly the diameter of the orbit. That's huge compared to your arms and your thumb. It's enormous compared to anything you can build. Yet for stars, it's just enough to create a whisper of shift. That's the kind of scale that makes you exhale, because it means even when you bring a whole planet into the measurement, the universe still answers in tiny angles. That could feel discouraging if you framed it as we're too small, but it can feel wonderfully calming if you frame it as the universe is that vast, and we can still measure it. That's the quiet triumph of parallax. Not that the shift is big, but that it exists at all, and that humans learn to notice it. So the next time you hear a distance in light years, a small part of your mind can picture the method behind the confidence. You can imagine Earth on one side of the sun, then the other doing its slow blink. You can imagine a nearby star making its subtle jump against the far background. You can imagine a triangle drawn in invisible lines across space, turning a barely detectable wobble into a distance you can name. And once you can name a distance, the darkness between objects stops being a vague abyss and becomes a measured quiet. An ocean with known spans, a city with known streets, a sky that isn't just beautiful, but also readable, like a map you can trace with the softest touch. That quiet little blink of Earth, one side of the sun, then the other, does more than measure distance. It changes what the sky is to you. The moment you accept that you're comparing two viewpoints separated by months, you start noticing the bigger trick hiding in plain sight. Every time you look up, you're not just seeing far away, you're seeing long ago. Not in a spooky way, in a soft, unavoidable way. Light takes time to travel, and time is the cost of distance. The universe doesn't charge admission, it charges patience. You already touched this without meaning to. Moonlight is about a second old when it lands on your face. Sunlight is about 8 minutes old. The starlight from Proxima Centauri is more than 4 years old. Sirius arrives with about 8.5 years of travel behind it. The glow from a Milky Way's center, tens of thousands of years. And that faint smear from Andromeda, if you've ever seen it or pictured it, is carrying a story that began roughly 2.5 million years ago. The sky is a museum, and every exhibit label is written in light. That phrase can sound grand and dramatic, but it's actually cozy if you sit with it. Museums are quiet places. They don't demand you do anything except move slowly and notice. The night sky does the same. It isn't yelling information at you. It's offering you a gallery of old photons and letting your eyes decide how much to take in. The most relaxing part is that you don't have to time travel to experience time travel. You don't need portals. You don't need a flux capacitor. You don't even need pants if you're listening to this in bed and living your best life. You just need distance. Distance automatically comes with delay, and delay automatically turns into history. Even the act of reading these words is slightly in the past. Sound takes time to travel. Your brain takes time to process. The present is already a slippery concept in a small room. In space, it's even slipperier, which is strangely comforting because it means nobody else has a firm grip on it either. The universe isn't living in a sharp, perfect now. It's living in overlapping arrivals. So the question shifts from what am I seeing to when am I seeing it from? You can feel this gently with the nearest examples. If you look at the moon, you're seeing the moon as it was a little more than a second ago. That's basically now for human life, but it's still a reminder. You never see anything in perfect real time. There's always a tiny delay. Then the sun turns that delay into something you can actually imagine. 8 minutes ago, you might have been in a different mood. 8 minutes ago, you might have been standing up. The sunlight you see has been on the road since before you made whatever tiny decision you made a few minutes ago. It's a humble way to realize the universe isn't instantaneous. Stars take that humility and stretch it into something dreamy. 4 years ago, Proxima's light left its star. Where were you 4 years ago? Don't answer too loudly. This is bedtime. Just let the idea float. Maybe your life looked different. Maybe you were in a different room. Maybe you had different fears. That starlight didn't care. It started traveling anyway, crossing the calm gaps we talked about, those enormous, mostly empty lanes between stars, and it arrives with a kind of quiet loyalty, as if it kept a promise without knowing it was making one. That loyalty is what turns the sky into a history book that never stops arriving. And it goes deeper than just old light, because light doesn't just bring age, it brings evidence. The sky isn't merely showing you a past scene like a movie clip. It's showing you physical information, color, brightness, patterns, tiny variations. Astronomers read that information the way a detective reads footprints in snow. They look at the spectrum, how the light spreads into colors, and they find fingerprints of elements: hydrogen, helium, heavier atoms forged in stars. They look at how brightness changes, and they infer whether a star is pulsing, rotating, flaring, or living on borrowed time. All of that reading happens because the messenger arrives intact. So you can think of a light year as two things at once, without mixing them up. It's a distance ruler, and it's a delay stamp. The ruler tells you where the object is in space. The delay stamp tells you where the object is in time relative to you. Both are compacts. Neither requires panic. The museum image gets even sweeter when you realize the exhibits are layered. Look in one direction and you see a nearby star a few years in the past. Look toward the galaxy's center and you see tens of thousands of years. Look out to a neighboring galaxy and you see millions. Look out farther than your mind wants to hold comfortably, and you can see hundreds of millions, even billions of years into the past. The deep sky is like walking into a museum where each room is older than the last. And the lighting is always perfect because the lighting is the artifact. This is why astronomers love looking at extremely distant galaxies. They're not being dramatic. They're being curious. The farther you look, the earlier you're seeing the universe. You're catching it in younger stages, when galaxies were smaller, messier, forming stars more intensely, colliding and merging more often. You're watching the universe grow up, not by guessing, but by observing old light that finally made the trip. It's cosmic archaeology, except the fossils are photons. A fossil is relaxing in a strange way. Fossils are evidence that something happened, and that it happened long enough ago that it has settled. The drama is over. The story is fixed. The night sky is full of that kind of settled story. Even if the object is still active, the particular light you're receiving is already written. It has already left. It has already crossed the quiet. It arrives as a finished sentence that can soothe a restless mind that keeps trying to rewrite today's conversations. The sky doesn't rewrite. It delivers. And the sky is also honest about the cost of distance. A light year isn't merely far. It means the universe gives you the past in exchange for the far. You cannot have the far without the past, at least not through vision. Seeing is always delayed by travel time. Your eyes are not windows into now everywhere. They're receivers of arrivals. Even mirrors are like that. A mirror shows you the past too, just by a few billionths of a second. Ridiculous, yes, but still true. The whole idea becomes less alien when you realize you've been living with delay all along. Space just scales it up until your mind finally notices. That sense of noticing is part of what makes this topic so relaxing. It's a gentle shift in perspective. Earlier, the sky felt like a glamorous liar. Bright stars seeming close, dim stars seeming far, until you learn to measure. Now, it becomes something even better than honest. It becomes patient. The sky doesn't pretend it's showing you the present. It quietly shows you what it can show you, and it does it consistently. There's also a lovely, slightly sarcastic angle to this. Humans are always chasing live updates, live news, live feeds, live status. Meanwhile, the universe is sitting there going, sure, here's your update from 2.5 million years ago. Enjoy. And you do enjoy it, because the scale is humbling in the best way. It turns urgency into something optional. You can bring Andromeda back into focus for a moment. That soft oval in the sky, visible as a faint smudge under dark conditions, contains an entire galaxy of stars. You're seeing the combined light of countless suns traveling across the quiet intergalactic ocean for millions of years to reach you. And you're receiving it without effort. You don't have to earn it. You just have to exist in the right place with eyes. It's almost like the universe is giving you a bedtime story written long before you ask for it. Then there's the Milky Way itself, which is an especially intimate museum because you're inside it. When you look into the dense band, you're seeing a stacked depth of different distances and different times all layered on top of each other. Some of those stars are relatively near. Some are much farther across the disk. Some of the light has been traveling for thousands of years. That means the Milky Way in the sky isn't a single moment. It's a collage of moments, arranged into a glowing stripe that feels present because it's overhead, but is actually a tapestry of staggered thence. The word tapestry matters because it gives you permission to stop trying to isolate every thread. You don't have to dissect the sky to appreciate it. You can let it be layered. Your mind can rest in the idea that the universe is handing you a complex image and not demanding you solve it tonight. And if you want one more gentle, almost mischievous thought to carry, there's a sense in which you never see the present of anything far away, and yet it doesn't reduce the reality of what you see. The past is not less real. It's simply earlier. The light arriving from a star is real evidence that the star existed and emitted that light. The delay doesn't weaken the truth, it just places it on a timeline. That's why astronomy is so powerful. It turns distance into history, but the history is grounded in something physical that actually arrived. So, a light year becomes a softly magical unit. It tells you how far the message traveled and hints at how long the message has been on its way. Not as a confusion, but as a built-in wonder. The same ruler that measures the gap also measures the waiting. And the waiting is strangely comforting. You don't have to do anything while light travels. You don't have to manage it. You don't have to optimize it. It just moves steady as that cosmic metronome. And then, much later, it reaches you as a quiet sparkle in the night, or as a faint smear on a telescope image, or as a subtle brightness you can barely name. Your world is loud with immediacy. The sky is calm with delay. So when you lie there and picture those nearby stars again, Proxima, Sirius, Barnard Star, each one becomes not just a point in space, but a little window into a particular slice of your own past. For years ago, 8 years ago, 6 years ago, the universe is quietly handing you timestamps without insisting you feel nostalgic about them. It's simply reminding you that time and distance are woven together by travel, and the thread is light. That thread keeps arriving, and you keep receiving, and the night sky keeps being a museum that never closes, quiet, enormous, patient, filled with exhibits that don't ask you to stand up straight or read the plaque. They just glow. That museum feeling of the sky, old light arriving, quietly stamped with history, leans on a promise you've been holding since earlier. Through empty space, light keeps the same pace. It's the dependable courier, the cosmic metronome. Relativity slides in with a sleepy grin and says, "Cool." That pace stays the same even when you chase it. That's the prank, and it's surprisingly gentle. Your daily intuition expects speeds to stack. Walk forward on a moving walkway, and you're faster than someone standing still. Throw a ball from a moving car, and it carries the car's speed. Your brain loves addition. Light refuses to play. Shine a flashlight while standing still, and the beam races away. Shine the same flashlight while you're moving, driving, orbiting, rocketing, and the beam still races away at the same speed. No bonus points for effort. The universe just repeats the same answer until you stop arguing. So if the speed of light is fixed for everyone, something else has to flex so the math doesn't crack. The universe chooses the two things you thought were solid: time and space. Time, the thing you feel as before and after, isn't a single global clock. It's local, like a diary kept by your own motion. Two people can compare notes and find different totals for how much time passed, and both can be right, because they didn't take the same path through reality. That sounds like philosophy until you picture it. You're on a train at night. Soft lights, steady hum, windows turning the outside darkness into a mirror. You flick on a little lamp in the middle of the car. In your seat, the light spreads to the front and the back and arrives at the same time. Symmetry. Calm. Someone on the station platform watches the same flash while the train glides by. The front of the car is moving away from the light. The back is moving toward it. If light speed is the same for the platform observer too, and it is, then arrives at the same time, can't mean the same thing in both viewpoints. The universe doesn't let anyone declare a single, universal now for distant places. That's the part that feels like a soft magic trick. Simultaneity depends on motion. Different observers slice the same reality into now in slightly different ways, the way two people can draw different straight lines across the same map. Once that settles, time dilation stops being a weird rumor and becomes the natural follow-through. A moving clock ticks slower compared to a clock you keep beside you. Not because the clock is broken, but because motion changes how time accumulates between two observers. At everyday speeds, it's tiny. So tiny you won't jog to the mailbox and return younger in a way that wins arguments. If you try, the universe will still hand you bills and responsibilities. Relativity is not a life hack, but the idea is soothing because it's consistent. From your own perspective, your watch ticks normally. Your thoughts feel normal. Your heartbeat keeps its familiar rhythm. The strangeness shows up only when you compare clocks that have been moving differently. A classic way to feel that comparison without turning it into a math problem is the twin story. One twin stays home. The other takes a high-speed trip through space and comes back. When they reunite, the traveler has experienced less time. Fewer ticks on their personal clock. Not because the universe played favorites, but because their route through space-time was different. Space-time is just the name for the combined stage, space and time, once you accept they're linked. The speed of light is the rule that stitches them together. It's the speed limit of cause and effect, the boundary that keeps the universe from becoming one instant, overwhelming blur. Earlier, that limit felt protective. Here, it feels architectural, like a beam in the ceiling you never notice until you realize it's holding everything up. Even the stubbornness of light starts to feel kind. Try to chase a beam, and it still slips away at the same pace. No matter how fast you go, it doesn't become less fast relative to you. So the universe adjusts your measurements instead. Your time and your space shift just enough to keep the speed of light steady for everyone. That sounds like rulers and clocks are quietly conspiring behind your back. In a sense, they are. It's a friendly conspiracy. It keeps reality coherent. And it also explains why the light year feels so foundational. You've been treating it as distance. And it is, but it's a distance built from the one constant that governs how information can travel at all. Light doesn't just bring you postcards from far away. It sets the geometry of what far away even means and how the past can arrive into your present as an honest signal. There's a little sleepy sarcasm in that. Humans love to imagine the universe runs on our calendars and our common sense. The universe quietly centers its deepest rules on light instead. Not on your schedule, not on your opinion. Light gets the privilege of being the reference point. Everything else, space, time, your sense of simultaneous, has to make room. The good news is that the universe is fair about it. There's no hidden true rest where the real clock lives. No special viewpoint that gets the official version of time. The laws of physics work the same for everyone in steady motion. No favorites, no secret VIP section. So the museum overhead becomes even calmer. The sky is full of old light, and the delivery speed is steady, and the way different observers carve up now is part of the same consistent framework. Perspective mattered for parallax. Perspective matters even more here. The universe isn't lying when it looks different from different viewpoints. It's telling you that viewpoint is part of the measurement. Somewhere beyond your roofline Light is still crossing those long lanes you've been imagining, between nearby stars, across spiral arms, through the quiet ocean between galaxies. It arrives with the same pace, the same rules, every time. Time can bend, simultaneity can slip, distances can swell into light years and beyond, and yet the metronome keeps its beat. And that beat, steady, indifferent, reliable, is a surprisingly comforting thing to fall asleep with. That steady beat you've been holding, the universe's refusal to be rushed, starts nudging your curiosity in a quieter direction. If light is the courier, what does the courier's trip feel like? Not the star's drama, not the telescope's glass, not the scientist's coffee going cold, just the starlight itself taking the long way to you. Zoom in far enough, and light becomes photons, those tiny packets of energy that still manage to behave like waves when it suits them. The universe keeps that little double act around as a reminder that certainty is overrated. A photon doesn't carry luggage. It doesn't carry intentions. It simply leaves. And the soothing paradox is this. The journey looks impossibly long from your calendar and almost non-existent from light side of the story. For you, light is a long-distance runner. It leaves a star and spends years crossing darkness. For a photon, time doesn't stack up in the same familiar way. Keep it gentle and non-mathy. A photon doesn't get a ticking wristwatch on the trip. It doesn't experience waiting the way you do. It's like the universe doesn't hand it the concept of boredom. So you can hold two truths at once without forcing them to fight. Years pass for you, and the photon still arrives with an effortless immediacy, as if it never had to endure the years at all. That kind of contradiction is strangely relaxing. It makes your own impatience feel optional. Picture a nearby star first, one of those neighborhood lights from earlier. Somewhere around Proxima Centauri, a flare pops, just a moment of extra brightness. A flood of photons launches outward in every direction, a silent glitter burst into space. Most will never meet anything. They'll slide through the calm lanes between stars and keep going until the universe changes the rules, which it doesn't, at least not tonight. One photon happens to be aimed in Earth's direction. Not chosen, not guided, just geometry. The universe doesn't need purpose to create connection. Alignment is enough. It breaks free from the star's immediate neighborhood, hot plasma, magnetic chaos, and enters the wide, thin quiet between stars. Out there, the emptiness is almost kind. There's no air to push against, no friction, no sound, just a clean corridor of space where light keeps that same steady pace you've been listening to under everything. Most of the time, nothing happens. And that's the calm part. The photon simply moves. Sometimes, though, it passes through the galaxy's soft clutter, dust, gas, tiny grains floating like microscopic ash. Space isn't crowded, but it isn't perfectly clean either. A dust grain can scatter a photon, changing its direction, rewriting its destination. Some photons get absorbed and re-emitted at longer, warmer wavelengths, returning as gentler heat. Some vanish into paths that never intersect a planet at all. It's not hostile. It's just the universe being spacious and probabilistic. If your mind is looking for comfort, take it from the ones that arrive. Arrival is not guaranteed. That makes it feel like a quiet gift rather than a requirement. Your chosen photon keeps its line. Years pass on Earth. Seasons cycle. People make plans and unmake them. Meanwhile, the photon is still in transit, and it isn't doing anything dramatic. It's not trying. It's just being light. Eventually, it reaches the outskirts of the solar system. Gravity shifts the scenery a little, not by slowing light down in empty space, but by shaping the paths that objects and signals take through the universe's curved geometry. That's the gentlest way to say it. Gravity bends the stage. Light still runs at the same speed, but the stage itself isn't perfectly flat. The photon slips past distant icy bodies and thin clouds of particles, then crosses into the region where Earth's orbit lives. This is where the scale turns from majestic to absurdly intimate. Earth is small. Your room is smaller. Your eye is tiny. And yet the photon's path, set in motion years ago, ends here. The final act is almost anticlimactic in the best way. A photon reaches your eye and gets absorbed by a light-sensitive molecule in your retina. That absorption triggers a microscopic change. That change becomes an electrical signal. Your brain turns that signal into a single point of brightness in your perception. You call it star and keep breathing. A journey measured in light years ends as a whisper of chemistry. It's hard not to love how gentle that is. No crash, no fireworks, just a quiet transfer of energy into biology, like the universe tapping you on the shoulder without waking the whole house. And the photon carries information the whole way. Even without words, it arrives with a story in its color and energy. It can tell you whether the source was hot or cool, calm or flaring, rich in certain elements, moving toward you or away from you. Astronomers turn that into knowledge with prisms and detectors and patience. You turn it into wonder with a glance. You can scale the same idea without exhausting yourself. Imagine a photon leaving the crowded region near the Milky Way center. From your point of view, it travels for tens of thousands of years before reaching this part of the disk. Human history changes completely while it moves, and the photon remains indifferent, faithful to the same rule. Or imagine a photon leaving a star in Andromeda. Its trip lasts millions of years by your calendar, crossing that quiet intergalactic ocean where empty becomes the dominant feature. It arrives faint, softened by distance into something your eyes can handle. If you ever see Andromeda as a smudge in a dark sky, you're catching countless photons like that, ancient arrivals landing softly, one by one, on your retinas. And here's a sleepy thought that makes the whole thing feel tender. The chances of any one photon ending in your eye are unbelievably small. Stars emit ridiculous numbers of photons every second, flinging them outward in all directions. The fraction that ever intersects with Earth is tiny. The fraction that intersects with you is tinier. You're not being singled out, you're being intersected. Still, the universe touches you anyway. That's also why the night sky is calm instead of blinding. Distance spreads light out. The farther it travels, the more it thins, the more it arrives like a whisper. Light years are the universe's dimmer switch. They turn a star's fierce output into a gentle sparkle you can stare at without pain. And sometimes, on the longest trips, space itself changes the message slightly. As the universe expands, light traveling across truly vast distances can get stretched, its wavelength lengthening, its color sliding toward the red. Picture a rubber band being pulled slowly, not snapping, just easing wider. The photon arrives not broken, just translated into a softer register. That's part of why distant galaxies can look faint and warm, and why astronomers often listen in infrared for the stretched out notes. So while you lie there, the story becomes simple again. Somewhere far away, a star emits light without caring where it ends up. Most of that light wanders forever. Some gets scattered into new directions. Some gets absorbed and reborn as warmth. And some, enough, is delivered here quietly into your eyes, turning enormous distance into a small, calm perception. The museum overhead isn't only something you visit. You're part of the exhibit's final step. A photon crosses a gulf and lands without drama. A rule stays steady. A message arrives late and still feels perfectly on time because you're here to receive it. That quiet ending, one photon slipping into your eye like a soft tap on the shoulder, makes the whole universe feel strangely personal. Huge distances, tiny arrival. A message that traveled for years, sometimes millions of years, and still lands gently enough that you can keep your eyelids half lowered and not miss the feeling. Then you notice something else that's been present the entire time, hiding in plain sight like lint on a black sweater. Between you and the stars, there's dust. Not the dramatic, choking kind that makes you sneeze in a sunbeam. Although honestly, it's the same concept. Tiny grains, microscopic bits of carbon and silicates and ice drifting through space. The galaxy's confetti, the universe's housekeeping problem. And the more you learn about it, the more it starts to feel like a curtain you didn't realize was hanging in front of the night sky. The relaxing fact is that dust is one of the reasons starlight whispers instead of shouts. Stars are powerful. Their raw light up close is fierce. Even our sun can make you squint through clouds and turn summer into an argument with your own skin. So how does a galaxy full of suns become a soft band across the sky? How does a star a few hundred light years away look like a delicate point instead of a spotlight? Distance does a lot of the dimming, spreading light out until it becomes a faint drizzle. But dust does something even more bedtime-friendly. It takes sharpness and smooths it. Interstellar dust doesn't behave like a solid wall. It's more like a haze you only notice when you try to see through a long stretch of it. A few grains here and there don't matter. Over dozens, hundreds, thousands of light years, the effect accumulates. The light has to thread a path through a galaxy that isn't empty. Thin, yes, but textured. And that texture softens what arrives. Dust has two main habits that matter for your sleepy sky. It blocks light, and it changes light. Blocking sounds negative, like the universe is being rude. But it's not rude. It's protective. Imagine if there were no dust at all in the Milky Way. You'd see farther into the galaxy with your eyes, sure, but the view would also be harsher, more crowded, more overwhelming. The soft, milky band would turn into an intense glare in some directions, and the sense of calm distance might get replaced by visual noise. Dust quietly edits the scene. It turns the galaxy into a mood. This is also where that earlier thought returns. The sky as a glamorous liar. Bright doesn't always mean close. Dim doesn't always mean far. Dust makes the line more convincing. A star could be near, but hidden behind a dusty veil. A star could be far and still visible because the path happens to be clearer. Your eyes get the final image, but the image has been filtered by the space it traveled through. The changing part is even more soothing because it's literally about making light warmer. Dust scatters shorter wavelengths of light more easily than longer wavelengths. In plain language, blue light gets knocked around more than red light. So when starlight travels through dusty regions, the blue components are more likely to be scattered away from your line of sight, leaving the redder components to continue toward you. The result is that distant objects can appear redder than they truly are at the source. You've seen a familiar version of this at sunset. The sun looks warm and orange or red near the horizon because its light is passing through a longer path of Earth's atmosphere. The atmosphere scatters blue light, leaving the reds to dominate what reaches your eyes. The galaxy does something similar with dust, just on a far grander scale, over far longer paths. So dust doesn't only dim starlight. It makes starlight feel like it's been put through a warm filter. Like the universe lowered the color temperature for bedtime. That's not a metaphor. It's physics doing mood lighting. If you've ever looked at photos of nebulae, those glowing clouds where stars are born or die, you've seen dust as both beauty and barrier. Some nebulae shine because they're energized by nearby stars. Others show up as dark shapes, silhouettes against brighter backgrounds. Those dark nebulae are dust clouds thick enough to block visible light. They look like holes in the sky, but they're not holes. They're places where the universe piled up raw material and quietly hid what's behind it. The Milky Way band you imagined from earlier, chalk on velvet, often has those dark lanes slicing through it. Those are dust lanes, and they're the reason parts of the galaxy look like someone gently smudged the light with a fingertip. The effect is almost painterly. The universe doesn't need to be artistic, but it keeps accidentally making art. This is where your mind can rest in a very simple image. Starlight traveling across light years is like a lantern seen through mist. The lantern doesn't change its intensity at the source, but the mist turns it softer, dimmer, more diffuse. The mist also changes the color, shifting it warmer. The distance plus the dust turns a fierce source into a whisper, and whispers are easier to listen to when you're trying to sleep. Dust also explains why some parts of the sky feel empty even though they're not. If you look toward the center of the Milky Way with the naked eye, you can't see the center itself clearly because dust blocks visible light along the plane of the disk. It's like trying to see through fog in a valley. The valley is full of landmarks, but the air won't let you see them. Astronomers get around this by using longer wavelengths, infrared, radio, because longer wavelengths can pass through dust more easily. That's a beautiful detail. The galaxy isn't hiding forever. It's hiding only from a certain kind of vision. The curtain is selective. The universe keeps secrets from your eyes, but it doesn't keep them from your curiosity. Even that feels soothing. There's always another way to look. Dust is also not evenly distributed. It clumps, it drifts, it gathers in the disk, especially in spiral arms where gas and dust pile up along those gravitational patterns. So the experience of looking across light years depends on the route the light takes. Some lines of sight are relatively clear. Some are dusty highways. That means two stars at the same distance can look very different. One arrives crisp, one arrives softened, reddened, slightly muffled. It's almost like the universe is teaching you that distance is not a single number. Distance is a journey, and the journey has weather. That weather is the interstellar medium, the thin mix of gas and dust between stars. Gas is mostly hydrogen and helium, spread so thin you'd barely call it a substance by Earth standards. Dust is a tiny fraction by mass, but it punches above its weight in how it shapes what you see. That's a comforting cosmic lesson too. Small things can matter without being loud. And dust has a deeper role that makes it feel less like a nuisance and more like a caretaker. Dust grains provide surfaces where molecules can form. They help cool collapsing clouds by radiating away energy, making it easier for gravity to pull material together into new stars. Dust is part of how the galaxy keeps making fresh light sources. It softens the light you receive, and it helps create new light to be received later. The universe recycles like it has nowhere better to be. That recycling adds a quiet kind of continuity to light years. The photons that arrive from distant stars are traveling through material that used to be inside other stars. Dust grains contain atoms forged in stellar furnaces. So the curtain itself is made of old stardust, hanging between you and newer starlight. It's like the museum isn't just displaying history, it's built from history. And your body already knows how that feels. You're made of atoms that were once part of something else. Carbon, oxygen, iron, elements created in stars and scattered into space long before Earth existed. When you hear dust, it can feel mundane. In space, dust is the residue of ancient suns, and it's drifting through the galaxy, tinting the light and helping build the next generation of stars and worlds. That's magnificence without strain. You don't have to reach for it. It's sitting there in the simplest word, dust. There's also a tiny, gentle consequence of dust that you can feel in the way the night sky looks from different places. In a city, artificial light washes everything out. In a truly dark place, the Milky Way brightens and the dust lanes become obvious. Dark rips through the glowing band. The contrast is sharper, the texture richer. It's not that the galaxy changed. Your local glare stepped aside and let you see the soft editing the universe has already done with dust. So the sky becomes less like a flat canvas and more like depth with layers. Bright star fields behind, dark dust in front, a glowing haze where countless stars combine, and all of it stitched together by light traveling for years through a medium that's thin but not nothing. And that medium can make the far feel softer instead of harsher. Over long light-year paths, dust dims and reddens. It turns bright into gentle. It turns sharp into smooth. It reduces the noise. The fact that the universe has its own built-in softener is oddly comforting, like discovering nature has a bedtime mode. A sleepy mind can appreciate this without doing any work. You don't need to compute scattering cross-sections or remember wavelength ranges. You just need the picture. Light leaves a star with a certain brightness and color, travels across light years, passes through a faint haze of dust, and arrives as a quieter version of itself. The message is still true, just delivered in a softer voice. It matches the way you receive information when you're tired. You don't want it shouted. You want it murmured. You want it warm, not blue, white, and sharp. Dust is the universe helping with that. Even the idea of things being hidden can be comforting because it means the cosmos isn't fully exposed. It has shadows. It has privacy. Some regions are veiled until you choose the right kind of sight to look through them. That makes the galaxy feel less like a harsh, clinical place and more like a real environment with corners and fog and quiet pockets. So when you picture those photons again, the ones leaving Proxima, Sirius, the Milky Way center, Andromeda, you can add one more layer to the journey. They weren't just crossing empty space. They were crossing a faint, dusty atmosphere of the galaxy, drifting through curtains that redden and soften, through lanes where the light becomes a whisper before it reaches your eye. And that whisper is the whole point tonight. The universe is huge, yes, but it doesn't arrive as a scream. It arrives as a softened glow, filtered by distance, filtered by dust, delivered by the same steady courier. A light year isn't only a measure of how far the message traveled. It's also a measure of how gently the message was allowed to become. That softened starlight, warmed by dust, thinned by distance, delivered like a whisper, has a way of making you wonder what else is riding inside those photons besides pretty. Because once you accept that light carries information, the next thought arrives on its own. Information about worlds. Not stars. Worlds. Planets aren't luminous on their own. They're shy. They borrow light. They hide in the glare. They don't announce themselves with a sparkling point the way a star does. Planets are the quiet roommates of the galaxy, always there, rarely introduced properly. So when people talk about exoplanets, planets orbiting other stars, it can sound like science bragging, like someone insisting they found something in a dark room without turning the light on. The truth is gentler and more impressive. You find them by watching starlight behave slightly differently than it should. You've already been living with the idea of patience. Light years are patience turned into a unit. Dust is patience turned into a filter. Exoplanets add another layer. Patience turned into a method. A planet crosses in front of its star from your viewpoint, and the star dims by a tiny fraction. Not dramatic, not cinematic. A small, careful dip in brightness, like someone briefly passing their hand over a lamp. That dip repeats on a regular schedule. Every few days, every few weeks, every few months, depending on the planet's orbit. The star becomes a clock, and the planet becomes the hand. Your eyes can't see that dip directly. Your eyes are poetic, not precise. Instruments see it. Scientists see it. Still, the concept is comforting in how delicate it is. A whole world reveals itself with a subtle shadow. No fireworks required. Then there's the star's wobble. A planet doesn't just orbit, it tugs. Gravity is a relationship, never a one-way pull. As a planet goes around, it causes its star to move in a tiny countermotion. The star shifts slightly toward you and away from you, and that changes the star's light through the Doppler effect. The same effect that makes a siren sound higher as it approaches and lower as it moves away. Starlight shifts in color by a minuscule amount, and from that shift you infer an unseen companion. Again, it's gentle, it's indirect, it's a lullaby written in tiny changes. So when you hear about an exoplanet discovery, what you're really hearing is someone listened to light patiently enough to catch a whisper of a world, and then the distance arrives and turns the whole thing into a quiet lesson in waiting. Because the stars hosting these planets are measured in light years. Tens, hundreds, thousands. The light you used to detect the planet left the star long before it reached your instruments. The news is always late. The galaxy doesn't do live updates. Take one of the closest examples because your mind likes to keep its footing. Proxima Centauri has that planet we mentioned earlier, Proxima b, roughly Earth-sized, orbiting close to a small red star. The system is about 4.24 light-years away. That number has a strange, emotional flavor. It's close enough that you can say it without your brain going foggy, and far enough that you immediately feel the delay. If there were clouds on Proxima b tonight, if there were oceans or rocky plains or winds sliding across a dark red dawn, you wouldn't be seeing tonight. You'd be seeing the version of that world from more than 4 years ago, because the light reaching you started out back then. For years doesn't feel cosmic. It feels personal. You remember who you were 4 years ago. You remember the texture of your life. So the idea that an entire other world is 4 years away and light becomes a special kind of calm. Not because it's reachable, but because it's imaginable. You can hold the delay without your mind snapping. Then you move outward a little to systems that have become famous for how many planets they host. TRAPPIST-1, for instance, is around 39 or 40 light-years away and has a compact family of planets, several of them roughly Earth-sized. That distance is still local by galactic standards, yet it's long enough that the light you see tonight began its trip decades ago. Not ancient history, just enough time for the world to change in quiet ways. You can picture it as a very slow conversation where each line takes a human lifetime to cross the room. People love to ask whether we could send messages to such places. Technically, radio waves travel at the speed of light, so the delay is the same story. 40 light years means 40 years one way. If you said hello toward TRAPPIST-1 tonight, a reply, if anyone replied, couldn't reach you sooner than 80 years from now. That's not pessimism. That's the geometry of patience. And it's such a clean kind of patience that it can actually relax you. The universe removes the pressure to be immediate. There's no rapid back and forth. No frantic typing, Babis. No, scene 2:13 a.m., heartbreak. Cosmic communication is slow enough that it becomes ceremonial. A message becomes an object you commit to, not a thing you fire off casually because your thumbs are bored. That slow pace can reframe how you think about existence elsewhere. You're used to imagining aliens as something that might show up with dramatic timing, arriving right as the soundtrack swells. But the reality of light years suggests a softer possibility. If there are other intelligences, they're living in their own now, and you're separated not only by space but by delay. Even if you looked right at them with perfect instruments, you'd be watching their past. Even if they looked at you, they'd be seeing Earth as it was long ago. It's humbling in the best way. It means the universe isn't built for instant recognition. It's built for long, quiet coexistence. Even the act of finding an exoplanet has that slow rhythm. A transit needs repetition. One dip in starlight could be a fluke or noise or a star spot. Several dips at regular intervals become a pattern. Patterns require waiting. You wait for the planet to come around again. You wait for the star to behave. You wait for data. The planet doesn't care if you're impatient. It will cross when it crosses. That's another reason exoplanet science feels strangely bedtime-friendly. It's about noticing small changes over long spans, which is basically what your body is doing while you fall asleep. Heartbeats, breaths, tiny shifts, repeating rhythms. The universe and your nervous system both understand that slow repetition is how truth reveals itself. And the distances get even more dreamlike when you step into the 1,000-light-year range. Some of the most famous planet discoveries from space telescopes come from stars hundreds or thousands of light years away. That means the light that carried the planet's shadow began traveling before you had any idea you'd be lying here tonight, thinking about photons as messengers. The discovery feels modern because it happened in a lab or on a screen recently, but the evidence is older. The universe mailed the letter a long time ago. Humans finally opened it. That's a relaxing contrast. The cosmos is slow, your technology is fast, and the intersection produces wonder on demand. Sometimes people imagine sending a spacecraft to these worlds, and a light year teaches you to soften that fantasy without killing it. 4 light years is already a staggering engineering challenge. 40 is a different category of challenge. Hundreds is beyond the kind of planning that fits inside a single human life. The light year, again, does its calm job. It doesn't say impossible. It says this is what far means. It nudges you toward a different kind of closeness. Closeness through light, through observation, through knowledge. That knowledge can be surprisingly intimate. From starlight alone, scientists can infer an exoplanet's size, its orbit, sometimes its mass, sometimes hints of its atmosphere. They can tell if it's puffy like a gas giant or dense like a rocky world. They can estimate temperature ranges. In some cases, they can detect certain gases in the atmosphere by seeing how starlight filters through it during a transit, like light passing through a thin veil and picking up a chemical accent. That veil image loops back to dust. Dust warms and reddens light across the galaxy. An atmosphere can also imprint itself on light in delicate ways. 2 different kinds of curtains, 2 different kinds of whispers, both telling you something about a place you'll never touch with your hands. And it's easy to get carried away and turn this into a loud hope story. The calmer version is better for sleep. Exoplanets teach patience whether or not they host life. They teach that the universe is full of worlds, likely unimaginably many, and the only way to meet them is through delayed light and careful listening. You can even feel that patience in the way habitable zone gets talked about. It's not a promise. It's a distance range from a star where temperatures might allow liquid water under the right conditions. It's a gentle maybe, and the universe loves maybes. The habitable zone around a small red dwarf is close in because the star is dim. Around a bright sun-like star, it's farther out. The idea is simple, but the implications are huge. Countless stars, countless zones, countless possibilities. And all of them are separated from you by light years, which means the story of any one of them arrives slowly. There's a particularly soothing thought that comes with that slowness. Somewhere out there, on some planet around some star, a sunrise is happening right now for them, and you won't see it until years or centuries or millennia later. The universe is full of private moments, not hidden out of secrecy, just hidden by distance. That makes existence feel richer and less urgent at the same time. You don't have to witness everything for it to be real. If an advanced civilization existed around a star 100 light years away and pointed a powerful telescope at Earth tonight, they wouldn't see you as you are. They'd see Earth from a century ago. Different cities, different technologies, different voices. They'd be receiving old photons the way you receive old starlight. Their version of us would be delayed, and ours of them would be delayed, and both would be true within their own light cones, moving through space-time at the universe's chosen pace. That pace can be calming because it removes the pressure to be seen, to be immediate, to be understood instantly. Across light years, everything is allowed to unfold quietly in its own time. So exoplanets become more than a catalog of distant rocks and gases. They become a lesson in slow connection. They show you that the galaxy is full of worlds, that worlds can be detected through whispers and starlight, and that any attempt to speak across that distance must respect the universe's speed limit. The light year stops being a cold measurement and turns into a kind of etiquette: patience, humility, long attention, no frantic demands. And in that etiquette, your own mind can settle. Messages don't need to arrive quickly to matter. Shadows don't need to be large to reveal a world. A tiny dip in a star's brightness can tell you a planet exists. A faint shift in color can tell you a star is being tugged. A delayed glow can tell you a whole system has been there for ages, living its own nights and mornings while you breathe slowly in your room, listening to the universe speak in the softest possible voice. That etiquette of distance, patience, long attention, the universe refusing to do instant replies, starts doing something comforting to your sense of place. Because once you accept that the galaxy is full of worlds and that even a simple hello takes decades to cross a modest gap, you naturally want one more thing before you fall deeper into the dark: a map. Not a tourist map with cute icons. A real map. The kind that turns the glamorous liar of the night sky into something honest and navigable. The kind that takes that soft museum of old light and adds labels that actually mean something. And the funny part is, you already own the first tool for making that map. You've been writing it your whole life. Earth's orbit, your planet's slow blink, gives you parallax. That tiny wobble in a star's position across 6 months is the most bedtime-friendly act of precision imaginable. It's literally perspective doing geometry. That one idea, scaled up with instruments that don't get sleepy, becomes the foundation for building a three-dimensional model of the Milky Way. So you can picture it like this. You're inside a vast city of stars, and your eyes are stuck at street level, looking up at lights that seem pasted to the same black ceiling. Parallax is the little trick that lets you measure which lights are closer, which are farther, and how the flat ceiling is actually deep space filled with layers. Humans started with that blink and then got ambitious the way humans do. Not loud ambition, quiet, spreadsheet ambition, the kind that says, what if we measured all of them? That's where Gaia enters the room, and it enters like a calm librarian with an absurdly big catalog. Gaia is a space observatory designed to do astrometry, measuring positions and motions of stars with extreme precision. It watches the sky over and over, not for drama, but for tiny shifts. It's basically parallax taken seriously enough that it becomes a survey of the galaxy. Instead of measuring a few nearby stars, it measures on the order of billions. Billions of points of light turned into coordinates, distances, and motions, the way a city becomes understandable once you have street names and a grid. And there's something deeply relaxing about that. The galaxy doesn't become smaller, but it becomes legible. Legible is a soothing word. It means you don't have to squint. You don't have to guess. You don't have to treat the universe like a vague mood. You can still feel the wonder, but you also get the quiet satisfaction of knowing your location in a structure that used to feel like a featureless ocean. Gaia watches stars wobble with parallax, just like the thumb trick and Earth's blink, except with the stability of space, without the blur of Earth's atmosphere, and with a precision that makes your human eyes look like they're trying their best and failing politely. Over time, those tiny shifts add up to distance measurements. Then Gaia also tracks proper motion, how stars slide across the sky over years, and it measures their radial motion in many cases, how they're moving toward or away from us. Together, that becomes a living model. Stars not just placed, but moving. That motion matters because your galaxy isn't a still photo. It's a slow dance. Spiral arms aren't rigid. Stars drift. The sun itself is in motion, orbiting the center, carrying you through the Orion spur like you're on a gentle conveyor belt of gravity. A static map is comforting, but a moving map is closer to truth. Gaia's data lets astronomers rewind and fast-forward the galaxy's choreography, tracing where stars came from and where they're headed. If you're lying there thinking, okay, cool, but how does this feel like a GPS and not just a giant spreadsheet? Here's the warm translation. GPS on Earth works because you have known beacons, satellites, with known positions and precise time signals. Your receiver listens to several at once and uses the time delays to infer where you are. It's basically triangulation with clocks. You don't have to feel the math. Your phone does the suffering for you. Space can have beacons too. The universe is full of objects that behave like lighthouses, flashing with astonishing regularity. Pulsars are the best example. They're neutron stars, ultra-dense remnants of massive stars that spin and emit beams of radiation. If the beam sweeps past you, you see pulses like a cosmic lighthouse rotating in the dark. Some pulsars, especially millisecond pulsars, keep time with freakish stability. Their pulses arrive with such consistency that they become natural clocks scattered across the galaxy. That's where the cosmic GPS idea gets delicious. If you can detect pulses from several known pulsars, and you know their positions and pulse timing, you can use the arrival time differences to determine your own position in space. Not poetic positioning like somewhere out there, but actual coordinates. A real place on the galactic map. It's the same logic as GPS, just with far older, far stranger satellites. And it has the same calming implication. Even in a universe measured in light years, there's a way to know where you are. Pulsars don't care about your emotions, which is part of what makes them so dependable. They don't get distracted. They don't go offline for maintenance. They just spin and spin and spin, sending out rhythmic signals across light years. The galaxy has its own beat makers, quietly keeping time while dust curtains soften starlight and planets cast tiny shadows. It's all one big system of signals, delays, and patterns. This is where all your earlier threads start knitting together. Parallax gives you distances. Distances give you a map. A map gives you context. Pulsars give you timing. Timing plus a map gives you navigation. It's patience turned into precision. Even the intergalactic ocean fits. Out there, between galaxies, things are too far apart for your brain to use familiar landmarks. But the principle still holds. If you have consistent beacons and you understand the speed limit, you can locate yourself by delay. The universe's refusal to do instant travel becomes, ironically, the reason navigation is possible at all. If signals were instantaneous, timing wouldn't encode distance. Delay is the whole language. And there's a quiet, sleepy pleasure in imagining a spacecraft far from Earth, deep in the solar system or beyond, listening to pulsars like someone listening to a distant radio station at night. The pulses come in, steady and spaced, and the craft uses those rhythms to figure out its position. No frantic recalculating, just listening. Listening is the theme tonight, isn't it? Light years teach you to listen to old light. Dust teaches you to accept a warmer, softer message. Exoplanets teach you to listen for tiny dips and wobbles. Gaia teaches you to listen for tiny shifts across a billion stars. Pulsars teach you to listen for rhythm across the galaxy's dark lanes. It's all the same skill, long attention without panic. Gaia's star catalog, in a way, is like turning that museum into a labeled gallery. You still walk through wonder, but you can read the signs. You can know that this cluster of stars is moving together because they were born together. You can recognize streams, trails of stars stretched out by gravity, like tidal ribbons, remnants of old encounters. You can see the galaxy's scars and its structure, the way a careful map shows you old riverbeds and fault lines. And if you've ever felt comforted by knowing your way around a new city, by recognizing street names, understanding which direction the river runs, feeling oriented, this is the same sensation scaled up. Your mind relaxes when it knows where it is. Even the idea of a reference frame becomes soothing here. Astronomers build a stable coordinate system for the sky using very distant objects, quasars and far galaxies, because those are so far away that, over human timescales, they barely shift in position. They become the fixed wallpaper behind everything else, like the distant mountain in the car window trick, except the mountain is billions of light years away. Against that near-immovable background, the motions of closer stars can be measured precisely. Remember that earlier image of the night sky being a glamorous liar? This is how you gently force it to tell the truth. You give a stable backdrop and watch the wiggles. You let Earth blink. You let Gaia stare. You let pulsars tick. The lies don't survive long attention. And none of this kills the wonder. It changes the flavor of the wonder. Instead of feeling lost in a beautiful haze, you feel held inside a structured enormity, like floating in a vast ocean while also knowing your coordinates and the currents. The water is still deep. You're still small, but you're not disoriented. There's also something comforting about how the measurements themselves rely on calm repetition. Gaia doesn't take one dramatic photograph and call it a day. It returns again and again, measuring, refining, improving. The galaxy doesn't reveal itself to a single glance. It reveals itself to steady care. That's a useful lesson for a mind that tends to sprint. Some truths only appear when you stop sprinting. Even the simplest outcome of this mapping is soothing, a better sense of your address. The sun is in the disk in the Orion Spur, about 26,000-ish light years from the center, orbiting at a steady pace. Nearby stars have measured distances. Clusters have identified ages. The galaxy's spiral pattern can be traced. The dust lanes can be modeled. The whole thing becomes less like a myth and more like a place. A place with a quiet, navigable geometry. So when you think about light years again, they don't just mean far. They mean mappable far. They mean measurable far. They mean the kind of far where if you keep your instruments steady and your attention patient, you can build a reliable picture. That reliability is calming in a way you don't always expect from astronomy. You come for the big feelings, the grandeur, the mysteries. You stay because the universe, underneath the mystery, is consistent. It has rules that don't change depending on your mood. It has signals that keep their rhythm. It has patterns that hold over vast stretches of time. And you, lying here, are allowed to borrow that consistency. You don't have to solve the galaxy tonight. You can just feel the comfort of knowing that the stars you see are not random glitter. They are coordinates in a map that exists, a map built from Earth's blink and Gaia's patience, and the steady lighthouse pulse of neutron stars ticking out time in the dark. Your room stays quiet. The fan hum stays steady. The cosmos keeps its rhythms. The distances remain enormous, but they stop feeling like chaos. They start feeling like a calm grid drawn gently over the night. That calm grid you've been feeling. Earth's blink turning into distance. Gaia's staring with librarian patience. Pulsars ticking like reliable lighthouses. Makes the universe feel strangely navigable. Not easy, not close, not friendly in a way a neighborhood is friendly, but knowable. And the moment something becomes knowable, your imagination shows up with a suitcase and a bad attitude. Because imagination hears light years and immediately tries to cheat. It wants a shortcut. It wants a trapdoor in space-time. It wants a button labeled warp that you can press with the same casual confidence you use to refresh a page. Humans are adorable like that. Give us a cosmic speed limit, and we respond by inventing a fictional lane that goes around it. Like the universe is a city with a single inconvenient road closure. Science fiction didn't start this habit, but perfected it. Hyperspace, warp drive, jump gates, wormholes, storytelling tools that let characters travel between stars without the author spending 3 pages describing how everyone got old and slightly resentful on the way. Which is fair. If every space adventure included a realistic timeline, half the plot would be the crew arguing about whose turn it is to clean the air filter. Still, there's a sleepy kind of joy in gently roasting those shortcuts, because the real universe is already magnificent without them. Light years aren't a problem that needs a hack. They're the whole point. They're what makes the cosmos feel like a place with depth instead of stage set. So the first calming truth settles in. If you respect the speed of light, even your nearby neighborhood stars are incredibly far. 4 light years to Proxima is close, only because the galaxy is outrageously big. 8.5 to Sirius feels like next door only because your mind has been stretched. If you try to travel those distances with anything remotely like current technology, you'll be working with time frames that don't fit neatly into one human life. This is where the universe's sarcasm shows up again. You've been enjoying how light is steady, faithful, never late. And then you realize that steadiness is exactly why you can't casually go anywhere fast. The same cosmic metronome that makes the sky readable also keeps you honest about travel. A light year isn't a suggestion, it's a statement. Even the idea of going fast gets weirdly human when you think about it. Your body feels speed as wind on your skin, vibration in the seat, the blur of passing scenery. Space doesn't give you wind. Space doesn't give you scent. Space gives you long, silent motion with no sensory feedback. You could be moving at thousands of kilometers per hour, and feel nothing unless you change speed or direction. That absence is part of why sci-fi loves dramatic effects. Stars stretching into lines, engines roaring, because otherwise the trip would look like nothing. Real space travel is mostly nothing, and that's not a flaw. It's an aesthetic. So when stories talk about jumping 100 light years, it's doing something emotionally useful. It's compressing the nothing into a moment so the characters can stay in a rhythm your brain recognizes. Meanwhile, the universe is sitting there with its enormous margins, quietly refusing to compress. Relativity doesn't just say you can't outrun light. It says something deeper and more calming. The rules are consistent. The speed limit isn't a punishment. It's structure. It prevents cause and effect from becoming chaos. It keeps the universe from turning into a tangled mess where everything happens everywhere at once. That consistency means any shortcut has to be more than go faster. It would have to change the geometry of the stage, space itself, or use some kind of loophole in how distances are connected. That's why wormholes show up so often in fiction. They feel like a clever solution. Not speed, but topology. Not racing across the intergalactic ocean, but folding the map so two distant points touch. It's a neat idea. It's also the kind of neat idea that comes with a suitcase full of yes, but in real physics. Wormholes show up as mathematical possibilities and certain solutions to Einstein's equations. But turning a mathematical possibility into a stable, traversable tunnel is a completely different vibe. The universe tends to be stingy about stability. Anything that wants to stay open like a shortcut would likely need exotic conditions. Things like negative energy density in certain configurations, stuff that's not sitting around in convenient buckets waiting for you to use it. Nature doesn't hand you a wormhole toolkit with your star chart. Warp drive concepts have a similar flavor. You'll hear about ideas where space in front of ship contracts and space behind it expands, so the ship effectively rides a moving bubble of space-time without locally breaking the speed limit. The ship isn't moving through space faster than light. Space is doing the moving. It's like standing still on a moving walkway and arriving at the other end without feeling the effort. As a concept, it's delicious. As a practical engineering plan, it's ambitious in the way only humans can be when they've had too much coffee and not enough humility. The math comes with requirements that currently look wildly out of reach, again involving exotic energy conditions and gargantuan amounts of it. Stories glide past that. Reality does not. And there's no need to be disappointed by that. Disappointment usually comes from treating fiction as a promise. Fiction isn't a promise. It's a dream with good lighting. The real universe is already delivering an experience that no warp drive can improve. You get to see time itself layered across space. You get to look up and receive old photons like letters that took years, centuries, millennia, or millions of years to arrive. You get the museum, the map, and the ocean all at once, without leaving your bed. That's the twist that makes the light year so relaxing. Even without travel, distance still reaches you. Information still arrives. The cosmos still connects to you through light, and it does it gently. It also reframes what exploration means. Sci-fi often treats exploration as physically going somewhere. Plant the flag, meet the alien, steal the artifact, outrun the consequences. Real exploration, especially at light-year scales, is more like listening, measuring, mapping, watching starlight for tiny dips and wobbles until a world reveals itself, letting Gaia patiently build a three-dimensional catalog of your galaxy, using pulsars like a quiet GPS, discovering structure through delay. It's exploration that rewards calm attention rather than speed. And speed is overrated anyway when the environment is this big. If you could zip from star to star instantly, the night sky would lose some of its depth. The distances would flatten into convenience. The galaxy would start feeling like a theme park map. Everything just a short ride away. The mystery replaced by efficiency. Mystery likes distance. Distance gives mystery a place to live. Even your earlier image of the galaxy having weather becomes more meaningful when travel isn't trivial. Dust lanes aren't just pretty. They're obstacles for visible light, curtains that make you switch to infrared if you want to see through. The intergalactic ocean isn't just empty. It's a quiet span that makes a galaxy feel like an island rather than a neighbor's porch. If you could hop across instantly, those environments would blur together. The pauses would vanish. The universe is written in pauses. So it's almost a kindness that there's no easy shortcut. The light year forces you to accept scale. It forces you to respect the difference between I can imagine it and I can physically do it. Your mind can cross to Andromeda in a breath. Your body cannot. That boundary isn't cruelty, it's clarity. It keeps imagination pure instead of turning it into a shopping list. There's also a second layer of gentle sarcasm. Humans often fantasize about outrunning light because we're impatient, but the moment you look honestly at what light years imply, you realize the universe already gave you a built-in time machine with a window seat. You want to see the early universe? You don't have to go there. You look farther away. The distance itself gives you the past. Travel becomes optional for wonder. And when stories insist on faster-than-light travel, they sometimes miss the most interesting thing about real faster-than-light. It would break the clean etiquette you've been enjoying. If signals could outrun light, cause and effect would get messy. Different observers could disagree not only about now, but about what happened first in ways that tangle into paradox. The universe would lose that calm structure where information has a speed limit. The speed limit is why the cosmos is readable. It's why the delay means something. It's why parallax works. It's why pulsar timing can act like a beacon system. It's why an exoplanet's shadow can be interpreted as a repeating pattern and not a meaningless flicker. The metronome under everything isn't just a number. It's the reason patterns stay patterns. So maybe the best way to treat sci-fi shortcuts is as bedtime metaphors. Warp is the feeling of wishing your worries were smaller. Hyperspace is the feeling of wanting to skip the boring parts. Jump drives are the urge to arrive without the middle. All very human, all very understandable at 2 a.m. The universe responds with a softer offer. Don't skip the middle. The middle is the magic. The middle is where light travels. The middle is where dust warms the message. The middle is where the intergalactic ocean holds its hush. The middle is what turns a point of light into a story. And once you accept that, the grandeur changes shape. Instead of craving a shortcut, you start appreciating the fact that a single photon can leave a star, cross light years of quiet, slip past dust curtains, and end its journey in your eye as a tiny spark of perception. That is a complete arc beginning, middle, end. No wormhole needed. Even the idea of distance ladders becomes more romantic than mechanical. Parallax for nearby stars, standard candles, and calibrated methods for farther ones. Redshift for the deep universe. It's all a layered approach, like the cosmos allows you to climb outward step by step rather than forcing you to leap. It's considerate in its own indifferent way. And the map you built in your mind, local stars as neighbors, the Milky Way as a city, the space between galaxies as an ocean, stays intact precisely because you can't shortcut it. You have to inhabit the scale. You have to let 2.5 million light years mean something other than just a number in a book. If you ever feel the urge to get impatient with the universe for being so big, it helps to remember how gently it communicates anyway. Light arrives from ridiculous distances and still lands softly. The cosmos is vast and still approachable through measurement, through patience, through the quiet reliability of its rules. Sci-fi can keep its warp drives. They're fun, they're flashy, they make good plots. But the real universe has a calmer kind of power. It makes distance itself into a story you can read, a story written in the slowest, steadiest language, light traveling over years. After all the talk of warp fantasies and cosmic speed limits, the quiet surprise is that you don't actually need a shortcut to feel the biggest distances. The biggest distances come to you anyway, one photon at a time, arriving late and still feeling perfectly timed because you're here to receive it. The scale can widen without your body moving an inch. The way thoughts drift far beyond the walls while the fan keeps its steady hum and your breathing stays slow. Light years have been behaving like a gentle ruler in your hands, stretching as the room expands. A few light years for stellar neighbors, tens of thousands for the Milky Way's far side, millions for Andromeda across that cathedral quiet ocean. Keep going, and the numbers stop sounding like travel plans and start sounding like weather systems, big, slow, and strangely calming. 100 million light years is the kind of distance where whole clusters of galaxies become the local scenery. At that scale, it isn't single spiral cities of stars anymore. It's gatherings, clusters, and superclusters, where gravity has been patiently pulling islands of light into loose communities. The universe, it turns out, has a social life. Not a loud one, more like a slow gathering where everyone stands far apart and still counts as together. And that togetherness has a shape. Over hundreds of millions of light years, galaxies trace filaments, thread-like structures of matter, woven around enormous voids. The voids of the universe's margins again, wide blank spaces where comparatively few galaxies live, and the filaments are the sentences, dense with light, curving and branching like roots seen in silhouette. It's hard to overstate how soothing it is that the universe's architecture, if maps of river deltas or the branching veins in a leaf ever quiet your mind. The cosmic web does the same thing on a grander scale. Patterns soothe. They tell your brain that chaos isn't the whole story. A billion light years sounds like it should come with a warning label, but the light year keeps doing its calm job. Distance, not time. Yet time always rides along because light travels. A billion light years means the light reaching you started out a billion years ago. Earth was already here, but it was a different Earth. Life simpler, oceans doing their patient work, continents rearranging themselves without asking permission. The light you catch from that far away is older than every human story, older than every language, older than every name you've ever known. And still it arrives as a faint smudge on a detector, a soft patch of brightness on a screen, a quiet receipt that says, yes, something shone there long ago and the message made it. Look that far and the universe offers its tender illusion. The farther you look, the younger the universe appears. Not because it's pretending, but because you're catching earlier chapters. Distant galaxies look wilder, not because space is playing dress up, but because you're seeing them in earlier stages. More chaotic, more actively forming stars, more likely to be caught in mergers. At those distances, even galaxies have baby photos. Those baby photos arrive redder too. Dusk can warm starlight by scattering away blues, and on truly vast stretches the expansion of space stretches the light itself, pulling wavelengths longer, shifting colors toward red. The message isn't damaged. It's translated into a deeper register, like a song slowed down without losing its melody. So the light year, which began tonight as a simple ruler, becomes a storyteller's timestamp printed into every photon. A nearby star says, 4 years ago. The galactic center says, tens of thousands. A distant galaxy says, 1 billion. Your ceiling turns into a layered archive with no loud exhibits, only quiet arrivals. And there's a comforting edge to the edge. Because the universe has an age, and light has a speed limit. There's a horizon to what you can see, the observable universe, the region from which light has had time to reach us since the universe became transparent enough for light to travel freely. That phrase sounds heavy, but the feeling is simple. There's only so far the museum extends, because even the best courier can't deliver a letter that started its trip before the postal service existed. That horizon isn't a wall. It's more like a fog line at sea. Beyond it, there may be more, almost certainly more, but the light from it hasn't had time to arrive. The universe isn't hiding it out of spite. Time is simply doing what time does. Inside that horizon, the distances become almost comically large, stretched by expansion while light was traveling. A gentle picture helps. The intergalactic ocean from earlier, except the ocean itself slowly widens, making the gap larger even as the light swims across. Light still moves at its steady pace locally, but the stage isn't frozen. The stage grows. It's the universe doing deep breathing. All that grandeur can sound like it's trying to impress you, but it doesn't. The most relaxing fact at the farthest scale might be that the universe doesn't hurry. It grows. It cools. It stretches light into softer colors. It shapes galaxies into filaments and leaves wide voids for quiet. It allows a photon to travel for 1 billion years and still arrive clean enough to tell a story. And you, right here, become the soft endpoint for a piece of that story. Your eye is where a journey across light years becomes a private experience. Your brain, the same brain that worried earlier about small things, turns ancient light into a calm picture. That's a connection built from patience. So the night sky overhead stops being a flat dome and becomes an enormous, layered landscape that's also a timeline, that's also a web. It's a museum, a map, an ocean, and a breathing universe all at once. And somehow it still fits into a quiet room with a dim screen and a steady fan. The glamorous layer of brightness and distance is still there. Dust still hides regions behind soft curtains. But you've been given tools. Earth's blink for geometry, Gaia's patient catalog for structure, pulsars for rhythm, and a light year as the calm ruler that keeps everything from turning into a pile of impossible digits. You don't need to solve the cosmos to feel it. The only requirement is accepting it as large and orderly at the same time, because that combination, vastness with structure, is why it feels relaxing rather than frightening. A chaotic infinity would be exhausting. A patterned immensity is comforting. It says, you are small and you are safe because the universe is not asking you to manage it. The biggest distances don't demand effort. They invite surrender. And surrender can be gentle, the way your shoulders drop when the day finally releases you. The universe is still out there doing its slow work, stars shining, dust drifting, galaxies gathering, space expanding. None of it requires you to stay awake. Your only job is to receive what arrives, and the rest can remain beautifully, peacefully out of reach. The pacing eases further, smoothing its edges so your mind doesn't snag on anything sharp. The billion light-year scale can soften into an image that barely needs focus. Filaments of galaxies like faint silver threads on dark velvet, with wide, quiet spaces between them, wide enough for thoughts to drift without bumping into anything. Light crossing those spaces doesn't struggle or hurry. It simply moves, steady and quiet, carrying a hint of color stretched into warmth. Breathing can fall into that steadiness, slow, and even a small rhythm inside a much larger rhythm. The fan hum can feel like the closest version of that cosmic metronome, gentle and constant, and the room stays exactly where it is while your sense of space grows kinder, as if the walls have softened into borders instead of barriers. Far beyond any streetlight glow, photons keep arriving from places you'll never visit, carrying old stories you don't need to memorize, only to receive, and that's enough. If your mind reaches for the farthest edge one last time, it can do it without urgency, like a fingertip tracing a constellation and then resting because the horizon doesn't press in. It rests where it rests, a calm limit that protects you from needing to hold everything at once. The night can hold what you can't. Galaxies can keep their distances, and light can keep its steady pace while your eyelids grow heavier and your thoughts thin out, spread wide, and soft the way starlight spreads across a long journey. Sleep can come closer in its own time, and the universe won't mind when you stop watching. It will keep shining quietly in the dark, faithful and unbothered, until the only distance that matters is the small one between your breath in and your breath out, slow and easy, like a whisper.